Hello, welcome to the day 2 of the first Raku Conference. So we had a really great day yesterday. Actually, we finished 1 o'clock in the night, my time. But today we have 7 talks. They're not that long as yesterday. Some of the talks are recorded. Some of the talks will be given live. So if the talk is recorded, there's no sense to interact with the speaker like via voice, but you can use the chat and the Zoom to communicate. And if the speaker is here, so they will be able to answer questions. So just raise hand in behind the reactions button, and you can be unmuted. So there are still some slots for lightning talks. If you want, you can submit it on the website. We still have only 4 lightning talks, so we have enough time to have more. Yeah, so that's it. So I would like to thank again our sponsors. It's pearlservices.de and Edument. They made a really great contribution. So yeah, so we will start now. So enjoy the rest of the day, and don't remember that we have 3 days instead of the single day conference that was planned earlier. Now we have 3 days, so it was a really good thing. So yeah, so I will in a bit I will pass the microphone and the camera to Liz, our first speaker for today. And actually yesterday, for example, if you watched the big class by Vadim Belman, he was explaining the details of Raku, which you probably never knew. And actually, the talk from Liz is kind of in that sense, also explaining some bits of Raku, actually Sigils. I don't like Sigils. I mean, yeah, I would prefer Raku would be like a language without them. But if they are, and actually, if you want to understand how to use them properly, just watch the next talk. So again, let's continue. And in a bit, she will introduce the talk, and after that, there will be a recording, and after that, there will be a question and answer series.
Okay, I guess I'm on. Well, or not. Am I on? Okay. Well, welcome to the first Raku Conference. I put together a presentation about sigils and twigils, and it starts about now, I guess. Andrew, take it away.
Hello, welcome to this presentation about sigils. Once you know them, you'll love them in the Raku programming language. But first, a little bit about myself. I got involved with Raku during the announcement meeting in 2000. I actually wrote some specifications in 2005, thanks to Audrey Tang. I got involved again from 2012, after being away from the project for about 7 years. Initially for documentation only, then I actually became a core developer from 2013 onwards, and I'm writing a weekly blog about Raku since 2015. So what is this presentation about? Well, it's about sigils and twigils, and this is what makes Raku different from other programming languages. And while looking at them, I'm going to introduce you to some strangely consistent features of Raku, more or less like a teaser, inviting further research by you. And finally, for those who dislike sigils, I'm going to introduce a way to write procedural code almost without them. And all of this is part of a little cinematic experience. So, what is a sigil anyway? A sigil is a symbol affixed to a variable name, showing the variable's data type or scope, usually a prefix, as in $foo, where $, is the sigil. This is a definition from Wikipedia. It actually comes from the Latin sigillum, meaning little sign, a sign or image supposed to have magical powers. So what are the 4 sigils of Raku? Well, let's introduce the main cast for this presentation, which is the $, the @ sign, the %sign, and the ampersand. So here you are, the 4 sigils of Raku. So let's have a look at the first one, the dollar, aka the scalarizer, aka the item maker, aka the one-trick pony. So let's suppose we want to create a lexically scoped variable with the name foo and put a value 42 in it. How does that look? It looks like this. We have a lexically scoped variable, that what the my indicates. We have a variable with the dollar, with the sigil dollar, with the name foo, and we use the equal signs to put the value 42 in it. So what does this display? This doesn't display anything because it doesn't output anything. Anyway, so dollar is for single objects. In Raku, everything is an object or can act as one. When defining variables with the dollar sigil, it binds to a container in which one object can be placed. And this is what we usually call a scalar variable. The container is what makes the variable mutable, but the container is also invisible when you're just using the value. So there's something in there that you usually don't see, but you should realize that it's there. It will actually help your understanding of how Raku works. So what if we want to print a string with $foo interpolated in it? Well, we print using say. We have a string between double quotes, and we just interpolate $foo in it. And what is the output of this? The answer is 42. So double quoted strings in Raku interpolate. You can use, you can also use the magic quotes and another selection of quotes, but I won't go into them right now. But they are basically just syntactic sugar for the QQ operator that allows more control in handling the interpolation. You can specifically say, I do not want to have scalar variables interpolated into this string, which can be handy if you have a lot of texts with dollars in them. And of course, say is just short for print with a trailing new line. It saves you typing 2 characters each time, and you don't need to add the new line. So what if we want to create a subroutine named bar, taking a single argument to be placed in the scalar variable? It looks like this. Sub is used in Raku to create a subroutine. The name just specified after that, and then between parentheses any arguments that you want to have. And in this case, we just want to have a single scalar argument, which will be collected into the $foo scalar variable. So how does this look? Not unsurprising, the answer is still 42. Parameters in a subroutine signature are by default bound to the value of the argument that is passed. So you can either create a new container for it, so you can actually mutate the value inside the subroutine by using isCopy on the variable, or you can force the argument to be a container by isRW, or you just don't care and you can say isRaw. Okay, well that's enough about the dollar, the scalarizer, the item maker, or the one-trick pony. Let's have a look at the @ sign. The @ I call the serializer, or the array maker, or the positionalizer. So what if we want to create a lexically scoped array with the name scores and put a list of values in it? It looks like this. We have an array, because we're using the @ sign here as a sigil. We give the name, scores in this case, and we put a list of values in it. That's it. So what does this display? Again, this doesn't display anything because we don't output anything. So a sequence of objects is what you actually get when you create define a variable with the @ sigil. And you actually create an array object, and it has containers in it, and that's why the objects are put in. It's what the containers is what makes the array mutable. The containers again are invisible if you are just using them. And maybe of note here is that the comma is what actually created the sequence of objects. So what do we want to print the first element of an array interpolated in a string? That looks like this. Note that you can use the square brackets there to index into the array and put the element there that you want. And the first element starts at 0. And that's the array. There you go. So what does this show? The score is 42. So when you're interpolating with an @ sign, they must be followed by square brackets, even if you want all elements, because what would happen if you had something like this in your text, send mail to bugs@raku.org? That would actually just try to access the @raku array, which probably doesn't exist, which would create an execution error or a compilation error. So what if we print the last element of an array interpolated into a string? It looks like this. Note that you cannot actually use negative indices while trying to index into an array. You can have a notation for that in Raku is a star -1. The star you should think about as the number of elements in the array. So basically you're saying number of elements -1, which basically means that you get the last element of the array because we start at 0. So what does this show? The last score is 314. So what we'd want to iterate over an array score is putting each value in a variable score and printing that. It looks like this. Iterating over something you can do with for. The array scores we specify there, and we can specify the variable that it should be put into with the minus greater than or little arrow sign, and we will print that. So how does that look? It looked like this. So about iteration, the for keyword allows you to repeatedly execute code on the source of values, which in this case would be an object doing the iterable role. The default variable bound on each iteration is $_. So if you don't want to specify any variable that you want to put your values in, you can just use $_. Arrays do the iterable role, so you can easily iterate over them. And other keywords for repeating code are while, until, loop, repeat while, and repeat until. So what if you want to create a subroutine that takes a single array argument and prints the whole array? It looks like this. We accept the argument there in an array, which means that you have to specify an array to get there. And we print it whole by just specifying nothing between the square brackets. And how does that look? Note that it just will put spaces between the elements so you can more easily read them. So the @ sign allows you indexing by number. It indicates an object doing the positional role. It allows indexing with the square brackets. Negative indexes are not allowed in Raku, but $*(-1) is. And the absence of indices means the object itself. And you can iterate, and when you iterate over it, it will iterate over its elements. So there you go with the serializer. So now have a look at the %sign, aka the hasher or the map maker or the associator. So what if we want to create a lexically scoped hash, aka associative array, with the name scores and put a list of keys and values in it? It looks like this. Hash because of the %sign. Again, the name of the variable that you create. And here we put a list of keys and values in it. Now you notice there that we don't actually just have commas there. We also have another symbol there. And that symbol is the fat comma. It basically creates pair objects. And the left-hand side of the fat comma is automatically quoted. It creates a pair object. So you can actually think of a hash as a randomly ordered list of pairs. So what if we want to print the score of UE? How does that look? Well, basically we index into the hash by specifying the string there. And that's how it looks. So what if we want to create a subroutine that takes a hash with scores and a scalar with a name as arguments and print the score of the given name? It looks like this. We accept a hash, we accept a name, and we print the score of the given name. So in the first case, we just show the name, and in the second case, we use the name to actually index into the hash. And that's just how it looks. So percent is for indexing by key. It indicates an object using the associative row. It allows indexing by string with pointy brackets. It allows indexing by expression with curly brackets. If you don't specify any indices, it means the whole thing. And if you iterate over it, you get the pairs of which the hash exists. So this is about the hasher. Now, let's look at the ampersand. The ampersand is special in the sense that you usually don't use it that much, but it is important to understand its functioning. So I call it the invoker or the submaker or the callabilizer. So what if we want to declare a variable that can contain a subroutine randomly selected from two other subroutines and print the result of calling that? It looks like this. We declare a variable. Note that we use the ampersand as a sigil. We randomly select from two subroutines. Note that we refer to the subroutine here with the ampersand. If you wouldn't put the ampersand there, it would actually call these subroutines, and that wouldn't work because you would have to specify a parameter for it. And we print the result of that. So how does that look? Well, you get either 43 or 52. I can't tell, it's random. So what about this random selection? Well, the roll method takes a random value from an object. This could be a list, this could be an array, this could be a hash, could be anything, really, as long as it has a roll method. The bool is the enumeration of true and false. Basically, you could think of it as a list of two elements, namely true and false. The ternary operator, the double question mark and double exclamation mark, returns the first value if the condition is true and the second if the condition is false. And note that you don't actually need to specify the ampersand there to call a subroutine in a variable. You can just use the name, like you would with a sub. So what if we want to declare a subroutine that takes something callable as an argument and print the result of calling that? It looks like this. Note that we use the ampersand sigil here to indicate that we want something callable, and we print the result of calling that. Again, if you want to call a subroutine inside an interpolation, you have to specify the ampersand there to indicate that what follows is a subroutine name. And you have to actually put parentheses there. So that was the result. On the interpolation of ampersand, as I said, it will return the value returned by the subroutine. It will interpolate the value returned by the subroutine call. It must be specified with parentheses to cause interpolation, even if the subroutine actually doesn't take any parameters. Because suppose you have a text like this: Ben and Jerry have the best ice cream. You don't want to actually want the executor look for a subroutine called Jerry that you probably don't have and cause an execution error. So what if we want to declare a variable for a callable and print the result of calling that? Now, here we have a special case of a callable. If we say *-1, we actually create a callable, similar to the -1 subroutine that we saw earlier. And we can actually call that. And it looks like that. So the ampersand is for limiting to code. It indicates that you want to have an object doing the callable role. Subroutines are callables. The body of a for loop is a callable. **-1 is a callable. And if you want to really find out what this is all about, look up whatever currying. well, actually, whatever currying. The emphasis there is important. So this is about the invoker, the submaker, the callabilizer, aka the ampersand. So if we look at these 4 sigils, then we realize that each of these sigils has its uses. Each sigil sigils some behavior, and each sigil indicates some kind of constraint. So enough about sigils. Let's have a look about twigils. So what is a twigil anyway? Well, we use the term twigil as a wordplay on the word sigil to indicate that it uses 2 symbols in front of an identifier. The second symbol placed between the sigil and the identifier. This is actually a definition more or less defined by our good Larry Wall when we actually introduced the twigil. So we have the 4 sigils of Raku, but we also have a support cast of the sigils. We have the twigils of Raku. Now I'm going to only look at 3 of them. There are more twigils, but you generally don't use them that much. So that's just for special cases. So here they are, the asterisk, the period, and the exclamation mark. So have a look at the asterisk. The asterisk is the dynamizer, or the whatever maker, or the lookup upper. It's basically, so what we want to have, the value of the environment variable user. It looks like this. So note that there's a hash that is available to all of your programs, but it's a dynamic hash. So that's why it has the asterisk in it. And it has the capital letters ENV for environment. So how does this look? Well, for me, it looks like this. On percent star event env, it actually shows you the current set of environment variables. Like other dynamic variables, they can be set lexically, and they default to the environment variables that the operating system has, that that your environment has at startup. So what if we want to declare a dynamic variable in a scope and have a subroutine print that dynamic variable? It looks like this. We actually have a dynamic scope there, a dynamic variable in the scope. Note the curly brackets there indicate a scope different from the others, a deeper scope. Have a subroutine, call that, print that dynamic variable. So how does that look? Well, for me, it looks like this. Note that the one in the middle is different from the ones on the outside. It basically switched back to the dynamic variables that was on the outside when we're out of the inner scope. $CWD is the current directory in the current thread in Raku. It's needed to avoid race conditions on file accesses, because it basically applies to all I/O operations used for relative paths. So if you want to change your current directory, it's as easy as changing that dynamic variable. And it defaults to the operating system's current directory at startup. Now, so Raku does not have a concept of a current directory as far as the operating system is concerned. It just basically puts that in front of any relative path that you are going to use in any I/O operations. So these are examples of the dynamizer. Of course, you can create your own dynamic variables if you want to create very nice libraries. The system itself uses dynamic variables quite a lot, for instance, in gather and take, and the react and whenever structures. But you won't see them because they're internal, but they're very handy to use. So let's have a look at the next twigil, the period, aka the methodist, the call initiator, or the selfie taker. So what should we do if we want to create a class that has a public attribute? Well, it looks like this. We create a class with the class keyword, and we create a public attribute with the hash keyword, and make sure that we have the period as the twigil. Of course, this doesn't do anything, so we don't have any output for this. So if you want to create your own class, you can use the class keyword. Well, that's very simple, isn't it? If you want to create a class with an attribute, you can use the has keyword. And public attributes automatically have an accessor method created for them. That's why they're public. And a new method is available to all classes by default, so you actually don't have to specify a new method. And you can set public attributes with named arguments to the new method. So how does it look to create a class that has a public attribute, create an instance of it, and show its name? It looks like this. We call .new. Note that we actually use a dot here as well. So that's why we call it the invoker. And we specify the name of the cat. And we show it inside the double quoted string. So that's how it looks. So if you want to interpolate objects into a string, it will call the string method on it. Interpolating a method call must be followed by parentheses, just like with a subroutine call, even if the method does not take any parameters. So that's not different from actually doing a subroutine call, but it basically makes sure that it does what you want instead of something else. So what if we want to create a class that has a public attribute with a default value, create an instance of it without giving a name, and show its name? We can actually do that by specifying a default value by just saying, okay, it's equal to this if I don't specify it. And we create an instance without giving a name. Well, we just say .new, and that's it. And what would that show? Well, it would show that the name is Spot. So that's why we call the period twice-yield the methodist, the call initiator, and the selfie taker. So now let's have a look at the final twice-yield, the exclamation mark, aka the privatizer, the invisibilizer, or the no. So what if we want to create a class that has a private attribute and a method using that attribute? Well, here we have a private attribute. Note that we use the exclamation mark as a twice-yield. And because it is a private attribute, there's no method then automatically created for you. So you can't call the .then method on this object. But we can create another method with the method keyword and actually use that private attribute inside that method and then call a subroutine, call a method on it. And in this case, I'm going to call the date on it. The default value that we specify there is what the private attribute will get as a value if we create the object. Since we cannot set it with the new, so this will always be the value that it will get. And now is a function in Raku to actually get the exact instant at this moment. So how would this look? Well, it won't look because we don't actually output anything. So how would it look if we actually create an instance of it and show when it was created? It looks like this. We create an instance of it. We don't have any parameters to it, so we can actually just say .new, and we call the method created with the parentheses in there. And how does it look? Well, on the day of this presentation, it would look like this. So that's about the privatizer, the invisibilizer, or the no, aka the exclamation mark twice-yield. So each twice-yield has a precise function, and each twice-yield indicates some kind of scope. So those were the twice-yields of Raku. Now we have the antagonist, the anti-sigil. Any good movie should have an antagonist. So here it is. And the anti-sigil is the backslash, aka the backslasher, the binder, the equalizer. Sorry. So what I want to create a constant named answer and show its value. It looks like this. The constant is created by using the backslash as the sigil, and answer is the name of the constant, and we can show its value. Now, if you look carefully, it's not that easy to actually show something that has no sigil in a double quoted string. So we have to do something here with the tilde operator. And the tilde operator is basically what we use in Raku to concatenate strings. Objects that are not strings will have automatically called the stir method called on them. And the reason for using the tilde is that it looks stringy. This is from the mouth of Larry Wall. The absence of a sigil, as you may have seen, makes it hard to interpolate. So what if we want to actually create a constant named answer and show its value? Well, there's another way of doing that, and it's in a double quoted string by using the curlies. And again, that's how it looks. So you can actually use curlies in interpolation, and the use of a curly inside an interpolation indicates that there is code in between. Any simple or complicated expression is allowed in there. Even multi-line expressions are also allowed. And the last value of the expression that you have in there will be interpolated. So that's how you can do that without a sigil. So if we want to create a subroutine that accepts a sigilless argument answer and show its value, it looks like this. Again, you can use the backslash in the signature of a subroutine to get a sigilless local constant. So if we want to create a sigilless variable bound to an array, and that array, of course, can be changed. It looks like this. Just use the backslash sigil again and make sure that we have an array pointing to it. You can use the square brackets, the circumfix square bracket operator to actually create an array in Raku. And we can change it, as we can see there. So how does that look? It basically added another element, number 3, with the value 99. So what if we want to create a sigilless variable bound to a hash that can be changed? It's the same thing, but you use the curlies to actually indicate that you want to have a hash. And of course you can change it, and you can index it into it by string by using the pointy brackets, and you can index it to by expression by using the curly brackets. How does that look? It looks like this. So what when you want to create a sigilless variable bound to a containerized value so it can be changed? Well, that's a little more tricky. It looks like this. We actually need to create a variable with a container assigned to that and then basically bind to that. And we can actually change that. But yeah, it's a bit meh. So there is currently no syntax to create a container with a value in it. Future versions of Raku may actually have such a syntax, but we don't know about it yet, and we haven't decided on that yet. But of course, you can create your own syntax now. I mean, yeah, it's Raku. You can do basically anything you want. So how would that look? Create a subroutine that will not decontainerize its return value and return a container with the value given. It looks like this. We actually specify the sub with the isRaw trait, and we put the trick that we just saw there with the extra nameless variable inside the subroutine. And of course, this doesn't show anything, but if we want to actually show that, we can just call the containerized subroutine. So basically, we have created syntax here for creating a containerized value. As you can see, it can change it. So that's about the backslasher, aka the binder, aka the equalizer, the anti-sigil. So getting back to sigils. Sigils allow for string interpolation of objects into your string. It also allows the naive reader of your code to see that a variable is actually being interpolated and it's not something else. And so it actually allows you for more compact code, and it basically would help you maybe in a few years' time when you're actually trying to read that code again. Sigils also basically allow the compiler to spot logic errors at compile time and spot logic errors at runtime. And basically, it also allows the runtime to actually create better optimizations. For instance, if a variable is known to have to contain something callable, when you call something in that variable, we don't actually need to check if that something in there is something callable or not, because the type of variable guarantees that there is something callable in there. So what if we want to actually call a subroutine that accepts a positional with an integer constant? So we have a subroutine from negate that accepts a positional, an array, that will become an array inside the subroutine, but we call it with an integer constant. So would that work? No, it does not work in Raku. It would be a compile error, because the compiler can actually determine that the constant int will actually never match the array. So you actually get a compile time error, which can be very useful in Raku or in a programming that language that you have, but the fact that it comes at the compile time saves you a lot of time. But sometimes the compiler cannot do that check. It basically, for instance, if you want to pass a variable to a subroutine, that can be an integer. The variable could also contain an array, so the compiler does not know at compile time what it's going to be. So how does that look? It looks like this, and this will become a runtime error. It will basically tell you that the type check, when binding to the parameter at array, expected a positional, but it got an integer. And it will tell you where exactly this went wrong. So it helps you with, helps the compiler, helps you with readability. And I think if once you're used to seeing sigils, they help you in understanding the code. And I mean, there are little signs that can have magic for you once you're sensitive to them. So you too can have magical powers in programming. And this brings us to the end of this presentation. And in good cinematic history, we show the main cast, the dollar, the @ sign, the %sign, and the ampersand. We show the support cast. In this case, they were the asterisk, the period, and the exclamation mark. And we basically note that it was lovingly brought to you by 900 plus contributors in over 22 years. So there we are. I will be taking questions in real time because this was a recording. But if you are looking at the recording, you maybe want to look at the documentation that we have on Raku, or questions that are being asked on Stack Overflow. So you can ask your own question there, or maybe find an answer in the questions that have already been asked and answered. You can ask a question on the Rakulang subreddit. You can actually ask questions on the Raku channel on libera.chat. And we actually also look at the Rakulang tag on Twitter. So if you have any questions, you can also, if you're using Twitter, you can also ask it there. Other useful links are raku.org, which is our main site. Raku.land shows modules in our ecosystem. The rakudoweekly.blog, which is our weekly blog about news from the Raku world, specifically for the Rakudo compiler. We have the Comma IDE. If you're a fan of integrated development environments, you should have a look at Comma, because that's the Raku IDE of choice. And if you're looking at creating web services, you would probably also want to look at Crow, which is a web services toolkit written in Raku for your convenience. And we have a RSS feed collector called planet.raku.org, which shows up interesting blog posts by people on the RSS feed. So thank you for watching, and hope to see you sometime again at a real conference. Take care, stay healthy. This isn't over yet, so be careful. Bye-bye.
Hello, I'm here to take your questions. Maybe I should just... Okay, I guess the first question that I didn't answer yet on the chat was, why is there no love for Perl 6 users at Perl.org mailing list? To be honest, I completely forgot about it because, yeah, I don't follow the mailing. I'm not on the mailing list anymore. No, that's not true. Actually, I'm on the mailing list. Anyway, I just forgot. I guess in any next version, I'll put it in there. Hopefully, it will actually get renamed by that time. Okay, I guess I'll just go back to all the questions that people have asked on the channel, on the chat. What is the general term to refer to Raku programmers? Raccoons. Personally, I like raccoons. It's what we use on the Rakulang Reddit. Yeah, there's that. I mean, Raku monger, meh, that doesn't sound right. So, yeah. Raku rollers are being suggested. Well, I guess, yeah, if you're more musically inclined, that would make sense. So, regarding say being shorter for print or put shorter for print, actually, neither are the same. Neither actually. They are all different, basically. Say calls the gist method and puts a new line after it. Put calls the string method after it. And print just doesn't do anything. Yeah, I'm not sure if I see any questions. Hands raised.
Liz, I raised my hand and I have a question.
Okay, there you go.
Can you talk a little bit about using the same symbols that we use for sigils as like contextualizers so that you can have, you know, hash ampersand variable name or rather hash @ symbol variable name so that you're still using the sigil, but you're using a different sigil as a contextualizer before it?
Yeah, the thing is, in the previous version of this talk, I actually mentioned it for using it as a contextualizer, and then I found out that, and actually during making that presentation, I actually changed the core to actually make it more sensible in my book. It didn't break any spec tests, but it broke some modules in the ecosystem. And so I reverted that. And so I sort of chickened out on that, on the contextualizer thing because I don't think that the behavior at the moment is completely consistent.
Oh, okay. I didn't realize that.
Yeah. So, I mean, you can put a dollar in front of, you can put, say, dollar parens open, value parens close. And you might think that it actually creates a container, but it doesn't. Whereas if you put an @ sign, parentheses, put something in between, it does create an array. And if you do the same with a hash, it does create a hash. So I found that to be inconsistent. And yeah, I think this is a matter for further discussion. And so I didn't want to touch on it in this, what I consider to be an introductory talk. Does that answer your question? Okay. Any other questions? I guess Andrew needs to okay that or something. It's not something I can do. Question on the chat is, if Raku didn't have sigils and twigils, how do you think these could be replaced by something else in the language? Well, I guess if we're talking about twigils for attributes, I guess they could be another trait on the attribute definition. If you're talking about, yeah, I mean, you can already program without sigils, as I showed. So the only problem I really see is with some of the twigils that you somehow need to replace by traits. Anybody else for questions?
Yeah, Liz, I had a question about Slurpee twigils. The @ sign followed by the star is different from the star followed by the @ sign, and
yes,
that might be confusing for somebody who's starting in the language.
Yeah, I'm not sure if we consider that use of the asterisk as a twigil.
Okay.
It basically is more.
That's understandable. Yeah, yeah, and I would hope that we could break that out for newcomers.
Yeah. Basically, in that context, it more means whatever.
Okay.
Right.
Okay.
So it basically means, okay, I'll put whatever you give me into an array.
So we can think of the asterisk really as kind of a prefix on possibly a twigil variable, a twigil sigil variable.
Yeah, but I mean, that would have been nice, but there's also meaning in that, and that would actually clash. So that's why it became the secondary thing. So yeah, in my mind, that is more of a modifier on whatever you specify there rather than a twigil. But yeah, you have a valid point there. Maybe I should have mentioned that as a twigil. Good point. Yeah. I'll keep that in mind for the next version. Thank you.
Can you actually do a whatever star followed by a twigil, or is that not allowed?
I would have to try.
Yeah. Okay. Okay. No, I mean it makes perfect sense with using it. I mean, we are talking about basically Slurpees, right? We're talking about whatever star @ sign args is Slurpee args, right? I mean, I hope I'm using the terminology correctly.
I'm not sure if the star there would actually cause you to create a whatever code. I mean, the rules for that are somewhere in the documentation, and I must admit that I don't actually know the rules by heart. I know that the thing is, you use them for simple things generally. So you don't actually have to put in parens or curlies in places where it's just a simple thing like lowercasing something or doing something simple.
I think it's very, very powerful using the whatever star @ sign args for slurping things off a command line. I think it's wonderful, but people might confuse that with other twigils that are in common use, which again are your main 4 sigils followed by either a whatever star or a period or an exclamation point.
Yeah, it's a valid point, and I probably need to address that in a future version. Yeah.
Great. Thank you.
Thank you. I think we've reached the end of our time. I'm not quite sure, but
Yes, actually, yes, indeed.
yeah, 70:50 you said, Andrew. So I guess this is it. Well, thank you for your questions, and I'll be still online on the Raku channel and here to take any more questions if you'd like to.
Yeah, and thank you very much for being so precise, which is really important for the conference, especially when it's online. So the next talk here is Vadim Belman. So he will be talking about the parallelized and concurrent testing with test async. So we have 45 minutes, and this talk is live, so you can interact with the speaker. You can ask him questions directly in the chat, or you can raise hand and he can unmute you. So yeah, enjoy your next talk.
Okay, hello everybody once again, whoever seen me yesterday, and so we meet again. Do you see my screen? In chat window, I would like to see the chat window. It's so unclear. Okay. Okay, so my name is Vadim, as you already heard it. And I'm gonna fix a mistake I made twice, actually. I tried to fit this talk into format of a lightning talk, and it never worked. So I would like to fix this mistake and tell you about test async and why I think it should be interesting for you. Well, I have a habit of showing a lot of examples. And so if you want to follow my examples, you can clone the repository. And in the chat window, I have given the instructions, how to clone and how to, which directory actually contains the examples I'm going to be using. So first of all, why test async? A year and a half ago, I decided to make an experiment and create a windowed text mode framework. Like if anybody worked with Borland Pascal back in long years ago, maybe you remember TurboVision framework back then. There was a number of other frameworks of the kind. So I decided I wanted to have some kind of windowing system for Raku, and I decided to try to give it a try and implement. And I based the framework on event system, which in turn was heavily relying on threads. It used a lot of threads. And when it came to tests, I just realized that, well, using the core test module, it's using the Borland Pascal. Oh, sorry, it just on IRC, there is a notification that somebody noticed that I remember about Borland Pascal, so just a little bit of mess. So using the core test module causes me a lot of pain because it doesn't work with threading pretty well. So I decided to write my own test module, which would solve a lot of problems I was meeting. How? Well, the only answer to this question was I wanted my module to be a drop-in replacement for the core test. That was the only mandatory requirement aside of being threadable and concurrent and whatever else I wanted to see, but I want people to use my module too. And if they started using core test, I would like the switch to a new module to be as smooth as possible. So you can simply replace test with test async and things are going to be broken. I promise you. Targets which I wanted to achieve apparently thread safe, as I said, primary. Another target was I wanted randomized testing. Randomized testing is something I picked up while working on FOSWiki project in Perl, and they use inconsistent order of test blocks. They use phone testing system, but anyway, so they used inconsistent order to catch up possible errors where you forget something to clean up and it influences other code in an incorrect way and so on, so on. I'll get back to it a little bit later. And the thing I always like in any kind of software is simplicity of extending it. So I wanted the module to be extendable, easily extendable with third-party modules. So if you don't have enough in test async, you can develop something you miss in it, and you can add it, and it has to be easy. Well, hopefully I made it easy. And yes, support for non-standard test environments, it also belongs here, because if you need something aside of tab output, standard test protocol, you just write an extension for test async. Internally, I was targeting object-oriented architecture. That's something I always use. Even my small scripts I write for myself, they often based on classes, because simply when you get back to those scripts in years, it's much easier to remember what's been done and why it's been done this way or not other way. So event-driven as well. The idea of event-driven test module came to me from two sources. First, it was, of course, the framework I was developing back then. And also, long time, test 2, I think, in Perl, also using the event-driven approach. So I picked up that idea. A little bit about terminology. I introduced my own terminology here because I found nothing appropriate, actually. I don't know why. So first of all, I use term test tool. Test tool is actually a subroutine which does the testing. In core test module, they are just called subroutines or functions or whatever. But I call them test tool. So if you use OK, if you use pass, plan, whatever, those are test tools. Test suite in this terminology has two meanings. It's a set, a code block, logically bound code block, which runs some number of tests by invoking test tools. And test suite is also the object which controls this code block. Test bundle is an extension. So basically, it's like a module, even though it's, well, actually it's a role, but again, I'll get back to it later. And I have a reporter. It's a test bundle which implements output functions, reporting functions. So whatever you get as an outcome from your testing, it gets there through the reporter. So How things are built internally. Since it's object-oriented approach, everything is built around one single class, test async hub. And I call it hub because it's not the final class. It's a class which collects doesn't collect, but everything else binds to this class to form something final. By default and automatically, it pulls in aggregator role, which is responsible for event processing, and job manager role, which actually responsible for managing jobs. Job can be, it's a piece of code which does some kind of test, and job manager decides how this code should be run. And dynamically connected are test bundles and a reporter bundle. And eventually, out of all this, I produce test suite class. And this class is what I instantiate to get control objects for test suites. Here is a little bit about how it works eventually. So generally, we have a suite which runs a number of test tools. A bit earlier. Let's take one example. And actually, this is the test suite. And here we invoke a test tool. Don't mention it's just first example of several, and it's using core module test. I'll get to this. So test tool, say first one could be plan, second one could be is something, and last one could be is okay something or whatever, leaves okay. Each test tool eventually produces a sequence of events depending on what they are doing. One event is mandatory. It's an event which contains test results, apparently. Events are then fed to the aggregator role. Aggregator passes those events through a filter if one is installed by a test bundle. And filter can do anything. Filter can drop an event, it can inject another event or modify the event, whatever. So if you need to get into the chain and do something to the events, you normally would do it through a filter. Then events are streamlined in a single stream and sent down to reporter, which can report to user. Normally, this is TEP protocol, which we are all used to, but as well, it can write to a log. It's not implemented. It would require a separate reporter, or results of testing could be sent to a server. So I was keeping in mind that it's possible to create a test factory, for example, where you have a lot of testing machines around, and you can have one server which would collect test results, analyze them, report them, and so on. And with a specialized reporter, it is possible, and it's pretty much easy to implement, really. Okay, but this is basically a sequential, sequential scenario which we are all used to. And events here, they will be coming sequentially because test tools were called sequentially. But if you switch to a threaded model, if our suite contains threaded tests, which would emit events asynchronously and in parallel, whatever. Well, nothing changes. Test async is written in a way that it doesn't care whether your test environment is synchronous and sequential, or is it asynchronous and threaded. It doesn't matter. Bundles. Here, just simple way of declaring bundles, but I really must apologize because talking about workflow, I wanted to show you some examples first, just to see things in action. So typically when we start with testing, say we have 3 tests run sequentially, and we all know this outcome of the core test tool. But what if we change this test a bit? What if we introduce threads? And we need to run each test in individual thread, whatever the reason for this. So throws like is invoked in a thread. What we get here? Uh-oh. Look at the difference. Look here. And look here. What a mess. And sometimes we even get failures because it's a mess. The core test is not designed for threading, and to make things working correctly, we need to take special measures, and we have to fight for correct test outcomes. But here is test async, and we are back to normal. All I done, I replaced core test was replaced with test async, and one mandatory change. I cannot. It's not possible to use the standard start routine, but a method of test suite object has to be used instead. But it's really minor change, absolutely minor, because otherwise, as you can see, things are basically the same. And another thing which actually is gone now, you see, just to prevent the suite to exit preliminary, because if I just start threads, they may not finish before the main code exits. So I have to record all the promises returned by the start, and I have to await for them. That's what I do with the core, but I don't need this test async. I just finish, and the rest is done for me automatically. Test async will wait until all those drops, those are the most simple kind of drop in test async. So it will wait until all those drops are done. And as you can see also, this line, first line, it actually comes from here. So even though pass on the main, in the main script code was invoked last, but in the output it appears first, because for Raku it would take time to start a separate thread, and while it starts those threads, the main code could already be finishing its work. Okay. Sorry for repeating all this. And back to the bundles. So declaring a bundle is as simple as using a keyword bundle. That's all. Then when you need to create a new test tool, you just create a method and you apply test tool trait to it. And that's all you need. Nothing else. Here's an example implementation. Well, actually, to declare a test bundle, one would need a module from test async, which would provide you with test bundle keyword and with the trait. But otherwise, this is a typical test tool. You declare it in a test bundle, then you use test async, and then you just use your new test tool. And here we go. So first test tool passes because this is what it does. It checks if case insensitive comparison, well, actually lowercase comparison to full passes, and with bar, apparently it fails. Okay. And talking about the internal architecture, in the second example, I simply wanted to show you the inheritance tree of test async. So if you look at it, you see that, as I told you, test async hub class consumes job manager and aggregator class. Then we have a reporter, tab reporter, which is included for us by default. And because test bundles are roles, I create classes which consumes those roles, and I build inheritance chain of those classes. So reporter is a child of test async hub here, reporter class. Base test bundle, this is the bundle itself here as a role. And this is the class created for it, and it inherits from the previous class. And here is my bundle. And eventually the custom created suite class inherits from all those bundles and eventually from hub. So we have a chain of inheritance, which allows us to override other test tools or to override some internal methods of async hub. We can do a lot of things. Bundle is not only about creating own test tools, but it's about extending the module in many other ways. Another thing, what test tool trait does, it creates and exports a symbol for the method it is applied to. So we have method is full, and subroutine is full created for this method. It's a wrapper, which internally does some preparations, and eventually it calls the test tool method. And here is the demonstration of this, because I can use same test tool as a method on my test suite. This is important because when you create your own bundle, you can use other test tools from other bundles. You can use them as methods. And test reporter also, it's very easy. I wouldn't be showing you how to write a reporter. It's a matter for reading documentation. It's a little bit more complicated, but Declaring it is also very simple, and it requires 3 methods to be implemented. And that's all. Okay, even though I already used examples quite extensively, but here comes the real examples session. Okay. First and foremost, of course, parallelization. In some cases, and some modules are supposed to work in threaded environments, and we need to make sure that the code we wrote is actually concurrent safe. The best way to do so is to start many threads and run some tests in those threads so that we make sure that they can cooperate nicely and safely play together. Here is how we do it. So let's start with sequential example, just to see once again. So this is normal sequential example. I use this note here to indicate what subtest code is currently ran. And I use it because when I use PES or when I use some other test tool, they all go through an event subsystem, and the output could happen not when you expect it to happen, because events are being processed asynchronously. So to have synchronous notification of when my subtest has been run, I use node. Usually we don't need it. It's only for the purpose of demonstration things. Okay, here we go. All I do, I supply plan test tool with a named parameter parallel. And that's all I need. From this moment on, by default, all subtests will be run in their own thread. So here, in this loop, I start 5 subtests, and each will be executed in its own thread as I promised you. And another thing I want to achieve here is to make this demonstration even more clear. I want those subtests code to be synchronized. I want all of them to fire simultaneously. And I actually succeed with it. And I have an approach which I would like to share with you. So normally, if you think about parallel processes, we can think about them as of runners on a stadium, where they have to start at the same moment of time, and to guarantee that they start at the same moment of time, they use a starting gun. So I have a starting gun in the form of a promise, and no subtest code will start until the starter promise will be kept. But that's not sufficient, because threads are starting asynchronously, and they're starting pretty much unpredictably. And if I just keep this promise over here, it could happen so that some subtests already, some threads already started while others are still starting. So before keeping this promise, before firing the starting gun, I have to find out if everyone is ready. And here what I do. So I have top suit. And I have a number of subtests started. And top suite sits there in asking mode if everybody is ready already. And subtests are starting and signaling that they are ready, and they do so by keeping a dedicated promise here, which was generated for them outside of the thread in a loop. So I have an array of promises, and each promise is kept, and here the top suite is awaiting. Okay, since all threads are started and ready, we fire the starter, and subtests are started at the same moment. They resume basically at the same moment. So if I really need to test things in parallel, this is a good approach to synchronize and make sure that things are really being run simultaneously, more or less. Well, as much as it can be guaranteed by the thread scheduler. Next feature, random testing. Using random testing is as simple as parallelized testing. All I need is just to supply random named parameter to plan, and all subtests will be created in a waiting mode. They will not start immediately. Instead, they will be put in a queue internally, and then the main code will proceed as usual. And then when we finish the suite, it starts processing this queue, and it randomizes the order of subtests and executes them eventually. So in this example, we can see it. Main works goes first, even though we don't use parallelization, you see. But this pass gets done first. And then I have all the subtests in random order. 0, 2, 3, 1. Okay, do it again. 3, 0, 1, 2. So whatever. Why random testing? With this example, I'm trying to show you just a mistake which could be done in your code. It's probably not realistic, but in some conditions, something like this could always happen. So in my class, I generate a unique sequential ID for each instance of the class and store it in attribute ID. And then I expect for some kind of number to come outside. And then this method reports the difference between ID and the number. And it actually expects that ID is always greater or equal to the number. So that's why you must always get an unsigned integer here. And if you do just normal sequential testing, I'm sorry, it's wrong example. Yeah, if you do just normal sequential testing, things just work. No problem here. Okay, so we switch to random. Oops. And without random testing, this kind of error would have slipped away. But when we have randomized testing, we have different situation here. The problem happens because when I start subtest and create an instance of the class in subtest, I supply it with test number, and because it's randomized, whereas ID will always be sequential, there are possible conditions where n will be greater than id. This is always possible. And also, I would like to note that randomization and parallelization are not mutually exclusive. That's another situation which is very useful in some circumstances. As we all know, resources of our computers are limited, and if we run a lot of tests, a lot of subtests in a single suite, we might exhaust our CPU. To prevent this, test async limits the number of simultaneously run jobs. This number depends on the number of cores in your CPU. And if you have really many subtests and you want to run them in parallel, there would still be some amount of subtests waiting to be put to be executed. So like you have 5 being run currently in their own threads and 10 more awaiting. And as soon as one of the executing subtests finishes, a new one is picked from the waiting queue and started. And without randomization, the queue is going to be also sequential. And with randomization, you randomize this queue. So that, again, not only you run things in parallel, but the way subtests will combine with each other is also unpredictable. And it adds some amount of chaos to the testing, which allows to catch up with even more errors than before. So this is probably the most harsh testing conditions which could be created. And when? The other feature I missed a lot on many occasions. Somebody of you probably know about the module test when. By the way, how much time do I have left? Could you please tell me on the chat?
Yeah, you have to stop at 39 minutes.
Okay, so I'm over the time now. Okay, then basically I just was, it was enough to tell the main things I wanted to tell you. So just thank you everybody and hope you can find use for my module in your code. I think we have no time for questions left,
No,
as far as I understand.
We have 10 minutes more. Just
10 minutes more?
yes. Yeah.
Okay. Then really I wanted to tell about when, because we all know different modes of testing, stress testing, network testing, whatever. And it's not always we want to run all the tests we have, and sometimes it's necessary to limit. So for this purpose, I created a standard bundle when, and what it does, it adds additional named parameter to the plan, when, which limits the conditions under which our test should be run, like here. You see, it tells me the test is skipped because it expects conference testing. And conference testing here, it's not a variable in Raku, it's an environment variable. So if I do it like this, if I set an environment variable, it's, oh, it's conference, so I do run. But the standard test when module was insufficient to me because I had pretty much complex condition ones where I needed something more complicated that it provides. So I decided to provide support for conditional, combinations of conditions. One of them is all. So all I do is I pass a pair to my when named parameter, and the pair has two conditions, conference and demo. If I do it now, it tells me, okay, you are missing demo testing. I need demo testing or otherwise I won't be around. Oh, the conference demonstration. So this test to be executed needs both conference and demo testing variables. For simplicity, I don't request for underscore testing here. So it's added somewhere inside. Of course, some tests can be run only if we have a specific module. And I don't have this module, so this is some conditionally skipped. But what if I want to run this test anyway? Okay, I can add force condition. And here we go, the test is run, but the second test fails because it tests for the presence of the module. And here I just use another kind of conditional, any. And well, that's basically it. And actually, nesting of those conditions is not limited. I can use all, or I can do all, and blah, 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 something else, some other condition goes here. I mean, it's not a problem at all. And every condition will be correctly reported to you. So when you read the error message, you will know for sure what exactly you are missing to run this test. Okay. Okay, really. Also, a feature which I was always missing from other test modules. This test tool, I call this kind of, this family of test tools, test testing. What it does, it inverts the outcomes of the following tests. So if the following test fails, it will mark it as passing. If it passes, it will mark it as failing. The reason, we create a new test tool and we want to know if it works correctly. So of course we tested for positive outcomes, and that's fine. But what if we know it's gonna fail and we need to test exactly the case when it fails? Like here, we know that is must fail when it got two different values here. Well, we cannot use to do because it's not to do. Because if is would ever pass this test, it's totally incorrect. So test flanks takes care of this situation. And here what we get. The test is okay. It failed because we expected it to fail. And the comment of this test is preserved. So we know exactly why it failed. And we know exactly that things are working as we expected them. Okay, so I think it's enough for today. Thank you, everybody. Thank you very much. And if there are any questions and time for them. I'm sorry, my chat window always closes. Basically, if you have any questions, you can always come on IRC channel and ask me there. I'm not always writing there myself, but I'm almost always there to know that somebody is looking for me. So usually I'm answering. Andrew, are you there?
Well, I am here, but I'm waiting if somebody has any questions. There was one raised hand and the person is silent. So yeah. But yeah, nevertheless, so yeah, so the thing is that we're missing the applause, right? So we have some applause in the chat, but it's not like in the real conference when you really hear that. So that's the downside of the conference online. I even didn't imagine that this can happen. But yeah, so if there are no questions, then I think we will continue. So in a couple of minutes, there's the next talk. And actually, yeah, so again, if that was a offline conference, I would ask participants how many domains in the internet you can name which have the Raku in the first part, well, and like something in the top level domain. So one of them is raku.land, and actually this is the subject of the next talk. So yeah, so and still we have some places for lightning talks tonight, so you can submit from the website. So yeah, so enjoy the rest of the conference.
Comma includes an integrated test runner, and in Comma Complete, we can even run tests and collect coverage information. After the tests are run, which Comma is able to perform in parallel for us, it annotates our modules with the percentage coverage of statements in them. If we open up a particular file, we can explore it to find where we might be missing test coverage within this file. Many projects we work on will have dependencies on other modules. When we open such a project in Comma, it indexes all of the modules, including the transitive dependencies. We can then look through the source code of the modules that we depend on, and also open up this handy documentation view, which shows information about all of the types, methods, attributes, and includes declarator doc comments alongside them as well.
Okay, hi everyone. You can hear me, I suppose? I hope you can. Excellent. So I'll share my and I am hoping that you can see my slides as well. So thank you for coming to my talk. My name is José Joaquín Atria, and I normally go online by JJ Atria. That's in most places. So, and that's my website there, in case you need to contact me. So my talk is called Traipsing Through Raku Land, and unsurprisingly, I'll be talking about Rakuland. A little bit of housekeeping. These slides that I'm showing are available online at that URL. I can share this link also on the chat. And the site itself that I'm going to be talking about is Rakuland. We also have an IRC channel on Libera Chat, which is Raku-land, in case you want to join in for just to have a chat or ask questions or additional comments if you're interested. So we're a friendly bunch. Just drop in. So we built a Raku website. That's the core topic of this talk. By which I mean that we built a website using Raku. So Rakuland is integrally built using Raku. Well, I mean, there's a little bit of other, there's some make files, there's some Docker files, but the functional code in the site is all Raku. And I mean not just the site itself, but also all the tooling around it, all the code that we use for ingestion and deployment and everything. But we also built this website for Raku. So Rakuland is a browser for Raku distributions. And like I said, we've made an effort to keep all of the tools that we're using in the site as using Raku. And I'll talk a little bit about sort of what was the motivation behind that. The site refreshes itself automatically every hour. So all of the data that you see on the site is up to date to the latest hour. And in terms of sort of like the architecture of the site, all of the writes to the database, they only happen once when we ingest. So at the top of the hour, we fetch all of the information that we want, we put it into the database, and from that point on, the website is just read-only. It's like, in essence, it's a static site. And we've made some efforts in the site to have short, arguably pretty URLs that we can share, and you'll see some examples of those URLs in the talk. I've been using the plural in this so far because Rakuland is primarily a team effort. I'm doing the talk, but a lot of the actual work has been done by James Raspas, who you might know from other successful websites like Code Golf, which explains possibly why we decided to write a website, since there's a lot of experience there. But why did we do it? The main reason is possibly that we wanted to use Raku in anger. We wanted to really use it. We love Raku, we love using it, but we're often faced with this question: is Raku ready for production? And it's a weird question to handle, because people are not going to pay you to put Raku in production unless you can answer the question, but you can't answer the question until you put it in production and test it. So we decided that we were going to do it ourselves. Because even if you know that Raku can be used in production in theory or by other people, you don't know whether you can do it. So we wanted to see whether we could do it. We wanted to see how it would look to build a website in Raku. Part of that was also to try some of the technologies that have been developed by others, like Crow, or some of the database handling modules that we had never had a chance to use. Certainly not when there's actual data behind them. But also some of the tools that we ourselves had written. James works on a TOML parser. I have an HTTP client library. I also wrote that app Lorea, which is a tool to execute commands on file system changes, and we tried to use these libraries in the code to solve specific real problems and also to see how those libraries behave when we put them to the task. And all of these libraries have seen improvements because of us using them in the real world, in a sense. And we've also pushed fixes to other, or contributions to other libraries as well. We also wanted to build something that would be useful. Even though we wanted to try these things out, we didn't want to build something that would just, linger in some dark corner of the internet. We wanted something that we could build and put out there and for people to use. And it's important for us that whatever we're building is useful to the community. And James has a knack to identify needs that can be solved by simple websites. So again, that explains probably some of the rationale behind this. We also wanted a website that was easy to try things out with, to hack with, in part because we weren't really sure what sort of problems we would have, or what sort of tools we would like to try. We wanted something that we could just jump in and do, which meant that that it would help if the code base was small and familiar and relatively straightforward. So that explains partly why the code in Rakuland has been to whatever extent is possible. We've tried to keep it relatively small, no nonsense code in a sense. Now, the obvious question is, well, we already have a distribution browser in Raku, in the Raku landscape, modules.raku.org. And I'll say that we did not set out when writing Rakuland to compete with modules.raku.org. The project with Rakuland, like I said, was mostly for us to have a test bed where we could put these ideas to the test. And as good as modules.raku.org is, it didn't quite meet our desires. It wasn't written in Raku. It's not particularly easy to just jump in and try new things with, and it's not really what we were after. So we wanted to come up with some niche that we could fulfill, and we figured that this was as good a test case as any. So I'll take you through a little tour of what the website looks like, and what sort of things you can do with it. This is, of course, a work in progress. There's a lot of things that we're still working on, but this is what it currently looks like. If you go to the website right now, this is what you'll see: a landing page with information about some of the distributions. You'll have some additional lists of popular distributions or productive authors on the right. And of course, there's a search bar at the top. The URLs for the search are as straightforward as we could make them. And we tokenize distribution names using Postgres, which means that if you search for something like math vector, you will get the results that you expect. We also do autocomplete on distribution names, which means that often you don't actually have to run a search to find the module that you're looking for. If you actually go to distribution, you'll have a distribution page that will have some information about the author and metadata about the distribution. And we also render the README and the changes for the distribution. Most of the metadata that we have for the distribution, we try to parse from the meta-JSON whenever possible. That is our source of truth for everything in the site. We read the stars for the distributions from GitHub and GitLab at the moment. Adding more sources is possible, but we can't actually have an internal measure of favorites or likes for distributions because, like I said, this is in essence a static website. And we do render the README and the changelog if the distribution provides it. We make a best effort to render it properly. We also have an author page where we display the distributions of that author. The metadata for the author comes from FES Meta, which is so we integrate with this external tool. And like all of these other pages that I've been showing, this is paginated, and we show the same sort of like, the list of tags for the distributions and release dates and stars and all the obvious things. The tags, we have a tag page as well, and the tags are also parsed from the meta.json. We normalize them internally, which is something that modules.raku.org also does. And we try to show only the tags that we consider to be meaningful. And by that, currently, we mean tags that are used by at least 2 distributions from different authors. And modules.raku.org also does some of this. So in this sense, this process is similar. We have a page with recent releases as well, which is as close as we're currently getting to something that can be easily processed by third parties. So and this is when we start getting to the wish list for the site. There are other pages in the site, but I'll let you discover them yourselves. But we have a long list of things that we want to do with the website, which we haven't actually done, more because we lack resources than because we lack ideas. In particular, we want to expose more of the information that we have in the database. We collect a lot of information about the distributions, including dependencies and reverse dependencies, but we don't actually have an interface to currently display that data. And although we are working on having an API that can expose that data, we don't currently have it. We also don't have a way to render the source code or the rest of the documentation in the distribution. But all of these things are things that we're working on, and that we're basically making all the effort that we can to bring about. And in fact, some of the features that I've mentioned just now, like autocompletes or tag pages, were implemented recently, in part because of community feedback. This is, by the way, a really long list. And these are just the ones that I could think of. But that is only part of the story. So while we were building this site, we were forced, because of this core idea that we had, that we wanted to use Raku whenever possible. We came across a bunch of oh, I just saw that on the chat. Somebody has a dependency graph generator. Excellent. We should be able to use that. That would be great. I think the bigger question there is, how do we render on the page? But I guess we'll get to that. In any case, while working on Rakuland, we had a lot of, we bumped into a lot of, well, some of them were problems, but I guess I wanted to discuss some of these lessons that we learned while working with Raku in a real world scenario. First of all, Raku is a new language, and you can tell that it's new because it's rough around the edges in some aspects. There are some things that we have expected to see more developed, that we were a little frustrated at times to find that that we were not quite there yet. Syntax highlighting, for example, was one of those things that we're currently using a custom version of Rouge, which is Ruby. Nothing against Ruby, but we couldn't find like a tool to do the sort of syntax highlighting that we wanted. And Markdown parsing as well was also something that that was not as straightforward to use as we initially anticipated. And when thinking about deploying a website on production, one of the things that you try to do is to pin your dependencies. And likewise, we couldn't find a way to pin all of your dependencies, not just your direct dependencies, but also your indirect dependencies, like you would normally do with a log file or a snapshot or something like that. And if you're thinking about deploying something in a production environment, something like that might be a real hurdle. Interestingly, even though Raku is a new language, it's a new language with a long history. And with that long history comes a big baggage. There are a lot of, and this is more evident to us because we've been working with distributions. We've been trying to catalog and index all of the distributions that are available through the various ecosystems, and that means having to deal with a lot of legacy code and a lot of abandoned code as well. So every time we come across a meta file that is incomplete, or some license that is not using the standard name or something like that, we realize that that needs to be fixed. And if the distribution is abandoned, or the author is unreachable, or they've moved on from Raku, that is difficult to do. To some extent, this is something that like all languages will have to deal with, but it's a little bit of a disconnect when you realize, oh, Raku is new, but it's also quite old. Like, it's not old, but it's a new language with a long history. Also related to our specific problem space, Raku allows a lot of versatility. So for example, just in the packaging model, you have the notion of ecosystems that can coexist, one next to the other. We currently have 3 different ecosystems. We have P6C, we have CPAN, and we have Ceph. And actually, Ceph became kind of publicly available after we started working on Rakuland. And this, even though this provides a lot of power for the authors and for users, because it allows users to, for example, have several versions of the same distribution installed in their systems and loaded lexically in different parts of their code. That is very powerful, but it means that for us, there's a lot of questions that are hard to answer. Like, for example, how do we disambiguate distributions? What does it mean to render a distribution by an author when that same author can have released in different ecosystems, or even in the same ecosystem, different incompatible versions of the same distribution? Related to that versatility, Raku is extremely powerful. And some of the tools that are at our disposal have made working with Raku extremely pleasurable. It's just been fun, and a lot of the times we've had tools or pieces of code that we have used in other scenarios, and we have to port over to Raku. We realize that it's just very convenient to use. We started on this project because we love Raku, and if anything, we like it more now. In part because Raku is truly optimized for fun. It's just really enjoyable to use, and despite all of the hurdles that we've found, we just really enjoy using it. And I think that's something that we should feel proud of. Thank you. In answer to the initial question, is Raku ready for production? I guess the answer, as in everything, is it depends. But it's definitely a positive answer from us. It definitely works in production for us, and you can go to the website and try it for yourself. And I would encourage other people to try it for themselves as well, because the sooner we come across these real-world problems using Raku, the sooner we can fix them and make things easier for everyone else. Thank you, everyone. And I'll be glad to take questions or discuss some of these lessons. Somebody did, Liz mentioned on the chat that we should, something that I agree with. She said that we should suggest using FES going forward, and we agree. It's definitely of the three ecosystems that are currently available, it's the one that is favored by Raku Land. It's where we get, it's the one that is easiest to work with for sure. And Raku Land was actually, I think, the first website that could index the distributions that were released on that. So it's definitely the one we prefer.
JJ, one question for you in terms of, you mentioned things that you found sort of missing from the ecosystem. That were there any pain points with the Raku language itself that you encountered in deploying a site to production, or was it all just sort of things that don't exist yet in the ecosystem?
Most of the code itself for the site has been written by James. So it feels to me like this would be a question that I've been doing mostly like code reviews and encouragement. But I feel like James is probably the right person to ask this question. I think I think we, looking through the code, there are a couple of places where there's comments saying, I wish there was an easier way to do this. But in general, whenever we have come across a limitation like that, it's Raku itself that provides us the tools to navigate around it. There are definitely things that I think we can improve with, but in general, it's been. I don't think that the problems are with the language, but more with the things that we build with the language.
All right, thank you.
I will also, mention again, even though I've mentioned before, that we are very receptive to feedback from the community. So if there's anything, if you start using the site and you realize like, oh, this is not quite what I wanted, or this is unexpected, or this is really missing, please let us know, because we're very keen on bringing those things into fruition. And I'm starting to run out of time. So unless there's any more questions, then maybe we can leave it here. Well, thank you, everyone.
Right. So thank you very much for this talk. And now we continue. The next speaker is Jonathan Worthington. He is about to talk about the Raku API. And actually, he has another talk which is scheduled for later today.
Comma aims to make navigation around your program fast and efficient, and this extends to working with grammars. For example, here I am in a grammar rule, and I can use the goToRelated symbol functionality to immediately go to the action method. Inside of the action method, I get autocomplete of the various captures in the grammar rule. I can also go back to the grammar rule to see where a particular capture appears. If I'm curious how a rule is implemented, again, go to definition, takes me there, and I can also find out all of the different places in the grammar that use this rule.
So hello, hopefully you can all hear me. And loud and clear, somebody says. Perfect, excellent. So good local time. It's a lovely evening here in Prague, actually. And it's really exciting. We have this conference, the first dedicated Raku conference, and it's a pleasure to talk about some of the things that I'm working on. So it's a quite interesting time at the moment, because really Rakudo, the Raku compiler, is going through a couple of really quite sizable transformations. I've been around helping implement the Raku language for a while now, quite a while, I guess. I've been through some of the previous architectural transformations, but it's been a while since we've really changed so much. The two talks that I have today are about both of them. The talk that I'm giving now is about something called Raku AST. And the idea behind this is to create a document object model for the Raku language, and then to rewrite the compiler front end to use that. The other thing that we've been doing that's actually a little bit closer to fruition is called a generalized dispatch mechanism. This is going to be much less user visible in terms of any features that it provides, but hopefully will help us optimize a bunch of things that are awfully slow at the moment. Now, somehow I've ended up leading both of these. And if you're curious, how do I do this? There's kind of two things that I've realized are really important. The first one of them is denial. Denial about how much work it's going to be, because to be honest, if you kind of realized that up front, you probably just wouldn't get started. The second thing that's really important is stubbornness. So, once you get so far into it, you're like, well, I'm just going to finish this damn thing because I started. So that's the things that are carrying me through with these two. So into the details. Before we get going, I've talked a bit in the past about Raku AST, but a recap for those who haven't seen any of that before and are not sure why they might care about this. Today, this is kind of the situation that exists. We take a Raku program, we feed it into the Rakudo compiler. It's running on top of some kind of runtime, some kind of virtual machine. More VM is the usual choice. The program runs, and that's about it. So our relationship with Rakudo today is, this thing that we give code to, and it runs it. So, in terms of what's inside there, it's almost like some magical thing, and we don't really, unless you're someone who's actually actively working on it, it really is a pretty opaque bit of software. The thing about compilers, though, is that they know quite a lot about the language that we're working with. And it'd be kind of nice if we could ask them about that. So one thing that we might consider doing is telling it, oh, can you give me the AST? Now, this is short for abstract syntax tree. Tree is the same meaning as we're used to everywhere else in computers. Just like we have a file tree and there's directories, and inside of them there's more and more, as many levels deep as we want. And this is a tree that represents what the program is going to do. And the reason we call it an abstract syntax tree is because it's abstracted away some amount, and the amount varies, from the syntax of the program. So we don't care about comments or spacing or the exact placement of certain program elements, or sometimes there's two very similar ways to write the same thing, and it can get normalized away. So it's going to show us the code, but as a tree, and that sounds kind of nice, because you might think, maybe this will help me understand how my program is being interpreted or understood by the compiler. So you do it, and you get all of this stuff out, and what on earth is this? Yeah, the probable sensible response at this point is, well, I ain't gonna do this again, because this is so distant from the everyday Raku language we're working with, that we we might want to okay, yeah, we really don't know what's going on there. This thing that I just showed you is called cast. There's a lot of it, and it's a really quite okay representation of a Raku program if your primary interest is compiling it into bytecode. If you're not interested in doing that, then it's not really that useful. It's quite distant from the language itself. So the transformation that I want to see here is, instead of the compiler being seen as some kind of magical thing, I want it to be an accessible thing, or an open thing, something that collaborates a bit more with the developer, and that the developer can work with and make more use of in ways beyond just telling it to run code. At the moment, Rakudo is kind of a walled garden. It knows Raku really well, but it keeps all of the knowledge to itself. And yes, there are some modules that try and poke into the internals, and the kind of support policy on that is, if you break it, well, that's your problem. And this is sort of reasonable in that it's already an enormous task for the compiler team to support the language and avoid breaking things in releases when there's quite a big module ecosystem doing all sorts of things. And there's definitely been times where I've wanted to tweak things, and then I found, well, actually, we can't quite do this because we'll break some module, and we really don't want Raku to have a reputation of something where you can't trust to upgrade. So at the moment, you really don't get to take advantage of all of the things that the compiler knows and understands about the language. So in the Rakudo repository, there's a branch called Raku AST, and this contains the work in the direction of giving Raku a second form, which is not source code, but it's actually a tree. And you can actually run it in two modes. One of them, if you just run the compiler and don't put anything into the environment specially, you get access to all of the various nodes, but it doesn't compile your program using them. If you stick this Raku AST equals 1 into the environment, or you can put anything there that's considered truthy, it switches over to using a new compiler front end. And the front end is the bit that does the parsing and figures out what the code means. And if we do this, then we get a rather nicer bit of output. This sort of makes some sense to, I hope, the average Raku developer. So we have a compilation unit, that's the program as a whole, which consists of a list of statements. And then we have a statement that consists of an expression. And that expression is a call by name. The name is say. There's an argument list. And the argument list to say is using the reduce term. And we're doing a reduce over the infix multiply operator. And that is also taking arguments. And the arguments are the application of the infix range operator to two integer literals. That is rather more accessible. And these things are Raku AST nodes. In fact, if we prefix them like this, these are the exact class names of the nodes in the implementation of the AST. Unlike cast, which is this internal thing, Raku AST is a proposed addition to the Raku language. So the idea here is that we'll have a supported feature with a stable API. So you can do things like this. You can make a new node. Here I've made an int literal one. And then we can give it to the compiler through eval. So just like you can eval from source, you can also eval from a tree. And of course, that's going to be rather faster because it doesn't have to do all of the parsing and so forth. So in a bit, I'll show you a more interesting example where I take advantage of that. As I mentioned, we have this flag that we can put in the environment. And this enables a new compiler front end. This takes Rakudo source, passes it, and instead of constructing this internal cast representation, it constructs the new Raku AST. And then the rest of the compilation works in terms of that. This is still very much a work in progress. At the moment, it passes an actually rather pretty number at the time I went to check before giving this talk. It's 333 spec tests. I absolutely didn't do that on purpose. And I guess you'll believe me. If it was double that, I think you might have cause for some skepticism. But that is rounded up 25% of the spec test files. Now that might sound kind of a little bit depressing in the fact that I started talking about the idea of doing Raku AST a little under 18 months ago, and then you do the calculation and wonder how many years this will take. One thing I've discovered about the specification test suite while I've been working on this project is that actually lots of the specification test files make, well, there's two things. One is that a lot of them make incidental use of language features. For example, there's loads and loads of test files which are making use of, for example, whatever star on a method call, just because it's convenient. And it makes writing the test easier. But that's actually really quite a difficult thing to compile. We don't support that in the Raku AST-based front end yet. And so there's a lot of tests for features that we, in theory, can handle, but that we do not yet support because the test happens to use this other feature. The other thing, which is also kind of sensible, but again, sort of works against getting nice numbers here, is that a lot of the tests are examining the interaction of different language features. So, what happens if I, use an exception handler and inside of it, put a React block or something like that. And that means that, you might not be able to compile the test for exceptions if you can't compile the React block yet. So that's kind of an underestimate of how far things are, which is, I guess that's the way things go. One thing that is really nice about this, though, is that the actions get far, far simpler. Just going to glance at the chat because is anyone asking questions? No, they're not. Oh, someone pointed out that, yeah, there's been a historical transition here where the thing that came before cast was called past, which actually stood for parrot abstract syntax tree. And this is all kind of amusing because when we abstracted away from parrot, we didn't really know what to call the next thing, and Q came after P in the alphabet. So, there we are. And then, the language got renamed to Raku. So this just happily ends up with a nice alphabetic progression. So yeah, thanks for pointing that out. Okay, so continue on. Today, if you look at the Rakudo compiler front end, if you have written grammars in Raku, then part of it will look pretty familiar because the parsing is done by a Raku grammar. And then there's an actions class, which builds up the abstract syntax tree. And today it builds cast. And this is just an example I grabbed. It's not one of the particularly terrifying ones, but there's a lot of stuff going on in there. This compiles the gather statement, well, the statement prefix. And we can see that it's desugaring it into some call to gather. So we have to worry about that bit of the internals. And then it's doing something weird with nil, which I think is probably to enforce sync context on things somehow. And then it's marking the result as unwanted, which is part of sync tracking. And there's all sorts of things going on there. This is how it looks in the new compiler frontend. We just say, oh, make an instance of the statement prefix gather node. And you might say, why is there this weird R function? And this is one of the points where it gets really, really headachy to do these things, because Raku is basically implemented in terms of well, itself, and we need to sort of cut the circularity somewhere, and there's lots of little tricks we have to do to make this happen. And this is one of the things. We can't actually just import into the actions here the various Raku AST classes. We just end up having this thing. We might find a way to tighten that up later. Anyway, that's how it looks. It's much shorter. It really just says make this node and attach it to the tree, and that's it. So at the moment, this is where things stand. We on master, the actions class is something like 11,500 lines long. The Raku AST based one is like 2,300, and I would guess that that's easily more than half of what it needs to be. So that's a lot easier to work with, a lot more compact, and a lot more accessible, hopefully. Of course, the work goes somewhere. It ends up in the nodes. So I'd also then argue that it's actually being done in a much more focused way. The whole design that we've ended up with is really better object-oriented design than what we have at the moment. So let's move on. It's also not just smaller, it's also simpler. So at the moment, if you try and understand some of the things Rakudo is doing, it builds up cache trees. But then later on, it wants to say, oh, what kind of Raku construct did this come from? And then it has to do some analysis to figure out what it was. Sync context handling is a really painful example of that. The thing that spits out the, oh, you used this expression in sync context, and it's useless. All the useless use of errors are they're not terribly fun to calculate in the current design, and they come out much neater in the AST-based design. But as well as being a nicer architecture, Raku AST is also a base for a bunch of new features. And a standardized AST is really a prerequisite for a number of things that we've long hoped to do. Now, the big one, and the thing that actually got me into this in the first place, is macros. So a macro is a lot like a subroutine. The big difference being that it's called at compile time, and because we're calling it at compile time, we haven't actually, run the program yet, so we don't have any values. So instead, it receives the AST of the arguments. Now, in Rakudo today, there in theory is a macros implementation. It's marked as experimental, so you have to turn that on to get it. And then when you do, you realize that it's so limited, there's really nothing you can do with it. That's particularly interesting, because the AST arguments it hands to you are completely opaque. You can't ask, what sort of thing is this? With Raku AST, that will change, because now we have a standardized AST. So if you write a macro, once we get them implemented, using Raku AST, this will be a standardized part of the language, and you'll have an object graph that you can traverse, manipulate, analyze, and so forth. This will be really the thing that not just lets us have macros, but lets us have macros that can do interesting things. There's also been a long speculated feature called slangs. And again, there's some experiments in that direction. So the idea of a slang is, we have the grammar, and grammars in Raku are really classes whose methods happen to mostly be written in regex syntax. And just like any other class, we can actually mix in to a grammar and add extra rules or override existing rules. And a slang does that. It extends the Raku language syntax by providing extra grammar rules. There's a few problems with that. One of them is that those rule names aren't standardized at all yet. But the other thing is that there's no good answer about the semantics. People love talking about syntax, but semantics is the really interesting part, because just introducing new syntax is pretty boring if we can't say what it means. And there's not any good answers about that today. So this idea is really nice, but we haven't really seen it get used all that much yet. And if you really want to try and do the semantics bit, you end up using cast, and it's not really supported. With Raku AST, this problem kind of goes away because the semantics can be provided by producing Raku AST nodes, and the compiler works in terms of them. So if you call, if your custom rule passes a block, then the thing you get is the Raku AST block node. And then you produce some more Raku AST, and whatever was the entry point to the bit of the parsing you did will understand the result. So these pieces should all just fit together very neatly. Another thing that we can do will be to introduce custom compiler passes. So we can have modules which export extra passes through the compiler. What do we mean by a pass? Well, compilers operate in stages, one after the other. So they pass and build up some AST. And then that is checked in various ways to make sure there's not problems with it. Then we optimize it. Then we turn it into to bytecode, and that all gets assembled and either run immediately in memory or written out to disk. But what if you could insert your own phase into this process? So you could say, for example, I have a module that's doing, for example, HTTP routing, and there's various mistakes you might make, like duplicate routes. And we could actually insert or export a custom compiler pass that detects all of these at compile time and tells you, oh, hey, you've got a problem here. Or, you could do custom type checking things. So if you write a module to do unit types, then you could actually, at compile time, forbid calculations that are badly formed in terms of the units. So that's an interesting kind of opportunity. So here's and all of these are very much proposals and things that I would like to see happen. But having just gone through them all, this is a little summary of what they are and how they work. So macros happen at begin time. That is, as we're passing the code, and as soon as we've passed the arguments to it, you can write them in the same file that you're compiling, or you can put them in a module and export them. They work lexically. Everything works lexically. Lexical scope is one of the things that keeps all of this sensible and under control. In terms of what you can actually do with syntax changes in macros, you're kind of restricted to operators and terms. And when there was work on formerly 007 Alma, which was a project to explore the idea of macros in Raku, one of the ideas there was to actually make macros applicable to lots of different kinds of language syntax. And I've kind of seen it, and my view on that is just leave macros for operators and terms, and anything more than that's a slang. Semantic changes yet to the AST arguments. So slangs by comparison, I think we'll probably always force those to go in a module and be imported, because the idea of inline ones in the current module breaks my brain. It might be possible, but I'm not keen. Again, lexical language changes in the scope they're used in. You can do anything with the syntax, behave, and semantic changes, yeah, to basically anything into the scope this is used in. And then finally, custom compiler passes. Those I would imagine will go at check time. That is, after we've passed all of the code and done the basic checks on it to make sure that there's not missing definitions of things and other invalid bits. Again, in a module, lexically applied where it's imported. And the most speculative line is that one at the bottom. Custom compiler passes are really quite easy to do once you have the rest of Raku AST. They're something that I imagine we'll get in right away. Macros, yeah, I'd really like to see them soon, but we'll see how it goes. And slangs, no, we're going to actually have to go and do a round of standardization on the language grammar to get to that, and that's another project in itself. So those are interesting, but I think probably a bit deferred. Again, very speculative, just my ideas of where things will be. So to round this talk off, I want to take a bit of a glimpse into the future and have a little bit of a look at what it might be like to use Raku AST, because now there's an increasing amount of it implemented. So it can be interesting to see that. So a year ago at a conference, I was complaining about one of my modules, and this module passes the JavaScript regex syntax and translates it into Raku regexes. And you might say, why do you want to do that? And the answer is that actually these show up in various standards, including JSON schema. So we can't just tell people like, oh, write Raku regexes in your JSON schemas. That isn't going to work as an open API implementation. So this module it sort of starts out nice. We use a Raku grammar to pass the regex. That comes out pretty fine. And then we need to produce the Raku regex, and we just smash together strings. And this makes me very sad because I'm a compiler writer and I just really hate strings. They bother me because I know that languages are complex things, and basically if you actually think about lots of security vulnerabilities, all of the injection attacks, all of them are because we just treat complex languages as strings and just concatenate stuff together. And that always makes me a bit wary. So I kind of would like to see this done in a better way. A year later, after I gave this talk, there's enough of Raku AST implemented that I could have a go at reworking the module. Of course, I can't publish this yet in terms of the actual module that's shipped, but the code is in a branch of the module as well. So I actually went through and converted quite a bit of it. I'll just show you some of it because it actually gets quite tedious and mechanical. So first, let's try and figure out how to get just enough so that if I compile the regex foo, then it matches the string tasty food. So I already have the parser, but I need to rework some of the action methods. But how do I know which ones? And I could go and read the code, but I'm really lazy. So what I actually did was just took the string foo and shoved it into this is the comma live grammar preview. If you're not using comma, I also wrote a module called Grammar Tracer, which does this as a command line thing and shows you what rules get used to pass something. So we can look at this and we can say, okay, well, those 5, I guess, disjunctional. Yeah, it's 5. Those 5 rules are things that I'm going to have to tweak the action methods for to get this first step done. So that's the grammar bits that go with those. And the reason I'm looking at this is because I want to know what these things are. And those that I've just grayed out we'll completely ignore for the moment. They're not important. So we're interested in alternation. That is where we have one thing or the other. And in the JavaScript regexes, it's written as a single vertical bar, but it actually has the Raku semantics of the double bar, the ordered tests. We then have the alternative, which matches a bunch of terms, and that's concatenation. So one thing after another. Then terms, okay, we all end up down in pattern character at the bottom there. That's literal. So I want to know about literals, concatenation, and alternation. How do I know which Raku AST nodes to use? Well, let's think about that. We could just ask Rakudo. You tried this. Cool. That tells me exactly what I need to know. So there's a quoted regex object. Well, that means I should do this in my top action method. I make a quoted regex. That's the node that goes with the pair of slashes at the start and end of the regex. And then the disjunction rule should make, well, actually we can be a little bit optimal here. And we can see how many different things are there. And if there's actually no alternation, there's only one option, we'll just extract that. And if there is multiple things, then we'll make an instance of the sequential alternation node. Sequencing looks very similar, sorry. So if there's just one term, so the A, B, or whatever, then we just hand that back. In this case, there's always going to be multiple things because of the A and the B there, but if it's just A, then we don't need to wrap it up in a regex sequence node. We could just hand the A back. Otherwise, we wrap it up in regex sequence, and pattern character, we make an instance of Raku regex literal, and we pass in the stringified match object, and we're done. Also, this makes me very happy because I have told the compiler, oh, these are literal characters. There's absolutely no risk of regex injection attacks in my translator now. This is making me happy. Two more action methods just need tweaking a little bit. This is just because term should pass along atom should pass along pattern character. There's no particular functionality in there. That's just passing things up and telling myself I've got a bunch of things still to implement. Plug it all together. So I write a method as AST that uses the same parser I wrote before. The action class is this new one I've started writing that builds a Raku AST. And then the compile method just evals the AST, and we get back the compiled regex. And oh, well, that gets rid of all the strings. That's kind of nice. Let's do a little bit more. Let's maybe do the quantifiers. And so this syntax on the right here with the curly braces turns into the star in Raku regexes. We'll see in a moment. This is the grammar rules that passes the quantifier. So you can see the plus, star, question mark there. The other alternative is the curly braces, where we say, okay, this number of things, and optionally up to, and optionally an upper bound, and that's what we need to compile. So once again, we can ask the Raku compiler, what sort of node should I be making here? And it tells me, well, you should make a quantified atom. And the quantified atom should have the thing that you're quantifying, the literal in this case, and it should have something about the quantifier. Okay, that looks kind of doable. So yeah, there's an amount of code, but if we look through it, the first thing then that's happening is that we need to deal with the is this a greedy match or a frugal match? That is, how does it match as much as it can and then backtrack, or as little as it can and then backtrack? We then take the type of quantifier we have, and then we just pattern match it with when. So if there's a from and an up to, then it's a range. If there's just a from, then it's a range, but actually it's an exact number of things. And when it's plus, then it's the one or more quantifier. And there's the other branches which look very, very similar. And again, that's it. We just need to tweak the term rule. So we say, well, when we have a quantifier, wrap it up in the quantified atom and pass along the atom there. And the quantifier that we made, remember, with topicalizers, so I can just call .made there. And that is it. So I have successfully got through most of the module. Actually, I stopped at some point because I was meant to write slides instead. But I've actually done the vast majority of it, and you can have a look at the Raku AST branch of that module if you are curious. After a while, it gets a fairly mechanical process. So that shows you a little bit of a glimpse into the future, but before we finish, I thought we'd just have one more. This is something that I just played with in the days before the talk. So I mentioned that whole idea of custom compiler passes. And I thought it could be interesting to try and actually implement one. So this is very provisional API that you're going to see in terms of the way this is done. It's also a pretty trivial example, but I think it shows off the power of what will be available here. And the simple example is we're going to add a check time compiler pass that looks for spelling mistakes in routines and package names. So the idea is that if I write this code and I import the module use code policy spell check names, then it will give me a warning if there are any words in my names here which are spelled in some kind of wrong way, or at least that are not in the dictionary. So, how do we write this? And you can imagine that if you all you had was access to source code, this would be quite an annoying thing to write, because if you only want to apply it to routine names and class names because they're API visible things, but we want to ignore things like variable names or things in strings or things in comments. Trying to parse all that out gets annoying. You can write regexes and then they'll work, 99% of the time or something like that. And it's all very wasteful because the compiler already did the parsing. We could just say, oh, tell me about all of the routines. So let's do this. First of all, this is nothing to do with Raku AST. This is just some spell checking bits that are here for completeness. So I just grabbed the dictionary file, lowercase all the words, made a set of them. And then I wrote two routines, check kebab case, which just splits a name up on dashes, and then checks if it's in the dictionary and counts up that it's wrong if not. Then we have check camel case. Yeah, the split is a bit cute there. It's using so the colon LU is saying that we want the character to match the letter the uppercase letter Unicode property. And then we stick a question mark in there, which means, oh, and don't actually eat the character, just match before it. And that is how we can split up camel case things. At least it's the first thing that came into my head to do it. So it works. I'm sure there's other cute ways to do that. The other thing I want to have is an exception type. This is just an exception class. It inherits from xconf, which normally isn't something that you would do, but it's the base class for errors that happen at compile time. And since we're writing a plugin to the compiler, then our errors happen at compile time. And then we'll just spit out the words that are misspelled. Finally, we get to the bits involving Raku AST. So here I'll write a subroutine spell check. It takes a node to check, and it takes the hash where we count up the wrong spellings. And I'll just do a give and when over this. So I say, when it's a routine, if it has a name, anonymous routines don't need checking, then check what it is in kebab case, canonicalize that name, because name is actually an object here. Raku names can be pretty complex. We just want the string. And we can do the same with package names, except those are camel case. So notice there's no messing around with strings here. We're just telling the compiler, oh, tell me about the process routines or process packages. And the final piece is the compiler path itself. I promise you this will not be the final API for exporting these. I'm pretty sure it'll be different, probably something a bit more objecty. But what this receives is the compilation unit. So that is the thing to check, and the resolver. And the resolver is it's involved in a number of things, mostly figuring out symbol resolutions, but it also is the thing that collects errors and warnings and so forth. So every Raku AST node has a visit method on it, and visits the children of a node. And if you return true from it, it also then goes on and visits their children. So we'll visit the whole tree. We call spell check on each node, which will match on routines and packages. And at the end, if there's anything wrong, then we'll produce the exception. So we run our program using this, and that is the output. At compile time, we have spell checked the routines and the packages. And that's not actually that much code to get involved in the compiler. That's relatively compact. So I think my time is about up. I'll use what last minutes I have for questions. The final thought I really want to have here, though, is that I think really Raku AST is exciting because it represents a change in the relationship between the Raku compiler and the Raku developer, where the compiler today is, this thing that we just give code to, and in the best case it runs it correctly and we're happy. And in the future it will be a much more modular and accessible thing, which will hopefully permit us to improve tooling in various ways, but will also, I hope, give us a better foundation for taking the language forward as well. So thank you very much. I suspect there are some questions in the chat, but maybe people want to actually ask them. There's so much chat. You folks have talked a lot. Yeah, anyone want to actually ask a question? Two people raised hands. What do we do about this? I am not an experienced consumer. Okay.
I think I got unmuted. Can you hear me?
I can hear you. Yes.
Okay, good. So question then about custom compiler passes. I sort of assume that those could be distributed as a pretty bog standard Raku module.
Yeah, they're just normal ecosystem modules that happen to export a compiler pass. I mean, it's a little bit in line with how today, if you want to export custom meta classes, then you just poke them into the export how package in the appropriate place, and the compiler pays attention to them. It'll be a similar mechanism to that. So yes, they'll just be normal modules that you import.
Very cool. Thanks.
Uh-huh. Okay.
Yeah. Hi, I have a question. Is the future of the comma editor to work directly on the Raku AST instead of just text?
That's a really interesting question. I don't know. So the thing about comma is that actually the thing that's really interesting about this question is that this all happened the other way around. Actually, comma uses I basically wrote a PEL6 grammar to Java compiler that is very specific to what the IntelliJ platform wants. That actually passes it into an AST, and that AST is very coupled to the details of how the IntelliJ platform works. But it turns out that given that I actually worked on that AST and now I am working on Raku AST, they are surprisingly well aligned already. They're not identical, and there's constraints that mean they can't quite be, but there's actually quite a bit of alignment. It's quite likely that what would really happen is that we'd further align the AST shape in comma to match up with the way that Raku AST looks, so that then we can do things in comma where we effectively match what the Raku compiler itself does with the AST as well. So that's probably how we'll do it. There's a bunch of different trade-offs in an IDE, but the answer is comma is already pretty into ASTs, and yeah, it's probably more strategic to maintain the two separate implementations and just have them well aligned. After all, Raku AST is meant to be part of the standard.
I guess it's my turn. This is Anton. I raised hand.
Yes, please.
I think 5 or 7 or 8 years ago, you talked about random generation of expressions or sentences from grammars. Do you think Raku AST can be used for a given grammar to generate, say, 100 random sentences, or even can go further? Can I generate, say, with Raku AST random Raku programs?
That's interesting. So that module that I wrote was always going to be extremely vulnerable to getting broken, and did get broken, basically because it pokes into compiler internals, and there's no good way to do that now. Do that at the moment. Yes, with Raku AST, it will be possible to implement that module in a much more robust way. Will it then be possible to apply that module to the Raku grammar itself? In theory, yes, but sort of, kind of, maybe. I don't know. It's sort of, there's so much little bits of interesting states going on when you pass Raku. That's kind of interesting. But in theory, maybe yes. But in terms of that module, I actually am inclined to revisit that module after Raku AST and actually rewrite it using this as an example of something that it's made possible to do in a good way.
Yeah, that would be great. I would say I have seen at least 5 or 6 systems for dealing with grammars. Very few can actually generate random sentences from grammars, and the grammars we call them production rules and whatnot. But many of these systems, you cannot use them to generate stuff with the grammars themselves. I'll be very interested to see the future of this work. Thank you.
Yeah. The production rules don't actually produce. Yeah.
Right.
Yeah. I think I have used all of my time and a little bit more, so I should be quiet. But yeah, I'll be back later for my second talk. Thank you very much for listening and for the interesting questions.
All right, I believe it's my presentation now, and I'm going to be talking about persistent data structures in Raku, which is a grant that I am work that I'm currently doing pursuant to a grant. Let me see if I can get the chat window here. Can someone confirm that you can hear me? All right, that is great. All right, so for those of you who don't know me and didn't meet me at my talk yesterday, my name is Daniel Sockwell, although you might know me better as Code Sections, the username I use online a lot. And as I said, this presentation is on persistent data structures, which I'm implementing for Raku. This is going to be a pretty quick talk, just 20 minutes, and I do want to leave a little bit of time for questions. So I'm not going to have a whole lot to say, but basically what I want to tell you is why I'm trying to add persistent data structures, how that will be implemented, and then little bit of time for bike shedding about the name of these different data structures, because I could use y'all's help. So as I said, this is a work that I'm doing pursuant to a grant proposal that I wrote and that was funded. I haven't done a tremendous amount of implementation work because there have been some logistical difficulties in getting a grant on the grant committee's end in terms of getting a grant supervisor and just the logistics of that. But I have started the implementation work, done about 20 hours so far, and I'm looking forward to doing a bit more as the month goes on. The first thing I want to talk to you about is this why question, though. Why did I propose this grant? Why was it funded? Why does it make sense to have persistent data structures in Raku? Well, basically, all of this comes back to immutability. As many of you, I'm sure, know, the immutability is extremely popular and extremely helpful in writing robust code, especially if you're writing in a more sort of functional programming style. Immutable data is much better for multi-threaded code because another thread can't change the data out from under you. Immutable data is just much easier to reason about because you know that the data you have is the data you put into that container or that variable. It's nothing else has changed it, especially as you sort of scale up and get to bigger and bigger programs. Having immutable data is extremely helpful. However, in many programming languages, having immutable data also comes with a pretty high cost because the main way, well, I mean, by definition, when you have immutable data, that means you're not changing your data. And that means that if you have an array of 1,000 elements and you want it to be an array of 1,001 elements, in a mutable world, you just mutate the array and add an additional element. In an immutable world, you need to allocate an entirely new array, copy each of the 1,000 elements into that new array, and then copy a 1,001st element into the array. That gives you a new copy that allows you to do the sorts of things that you might otherwise do through mutation, but while preserving all the benefits of immutability. That is great for sort of programmer ergonomics, but it is not very good for performance. It requires all of these copies. So the big idea with my grant and with shared persistent data structures is to say, how can we get the benefits of immutable data structures without the cost of copying all the time? And the basic idea, I want to show you this diagram here. The basic idea is that it is to convert your data structure into one that is somewhat tree-like, and it's tree-like both in the TREE tree sense and tree in the TRIE, sometimes pronounced try, like it has similarities to both of those data structures, but the basic idea is, as this diagram is illustrating, when you're adding this new C node, this new element to your array that contains the value C, all of the blue nodes and the pink or purple nodes here are actually added, but everything else is shared. So the idea in a sort of big picture sense is that you keep all of your shared data, you share as much of the old data as you can, anything that is totally unchanged, and then you add in sort of path copying to point to the specific data that you need to add, just to sort of track the changes. So how does that work under the hood? So under the hood, this is an illustration that I'm going to walk through of how this works internally, but what I need to tell you before walking through this diagram is here each of these nodes is shown with two children, which is to say this diagram illustrates persistent data structure with a branching factor of 2. That's just to make it fit on the diagram. In practice, the branching factor is usually much higher than that. It could be up to 64 for a 64-bit architecture. There's some sort of theoretical reason that 64 would be the best. In practice, 32 tends to be the ideal branching factor for reasons that have to do with cache coherency, and you actually end up filling up your cache lines and having some cache misses with when you go all the way up to a 64-bit branching factor that you can avoid with a 32 branching factor of 32. But that's something that I can play with and test out for Raku and profile as I develop this data structure specific for Raku. But so with all that said, imagine that in practice, this would be a lot more than 2 nodes, but the basic idea is you start with a head node that tracks how many items are in your vector, and then at each level, you either get to the leaf node or you branch out to another internal node, and then you get to a leaf node that has just the branching factor number of elements. So here 2, in practice, more like 32. And what that means is you can always access a particular element just by following a single chain down to that node. And to go back to our path copying example, if you want to append an element, you only need to change the path that takes you to that element. So the pink nodes here are the 2 that you need to add. The blue nodes are the 3 that you need to change. The orange are the nodes that remain. And as you can see, by following the arrows, the new blue nodes end up pointing to a lot of the existing orange nodes. So much of the tree structure is not at all, there's no need to copy the vast majority of it. Let me just check the chat to see if there are any questions. Yeah, this is somewhat similar to a trie with frequencies, but those are related data structures, although they would have different use cases. As I mentioned before, this is something that is a well-known data structure, and it's one that has been discussed in academic literature for the past 20 years. It's actually was implemented in Clojure a number of years ago as one of the sort of first features of Clojure for its 1.0 release. And so there is a lot of prior art that I'm sort of following along with. So that's part of the reason I think this was a good fit as a grant proposal is that it is sort of a well-trodden path, but it will get a feature that will help Raku be on sort of an even ground with other languages that support functional programming as well as Raku. Okay, so the last thing I wanted to talk about before turning this over to questions was bike shedding on the name, as I mentioned, because that's one area that I would like some help with. My initial idea, as I let out that, my initial idea, as stated in the grant proposal, was to call all of these hat. So you'd have list hat, map hat, set hat, bag hat, mix hat, etc. And the idea there was that the underlying data structure that backs each of these is frequently known as the hash array mapped trie. And to make that pronounceable, I was going to drop the M, which is not really essential to the name, and think of them as hash array tries. But I didn't love that idea, and I love that name. And then Jonathan also pointed out that sort of leaks implementation details. You know, it really isn't essential to these data structures that they're implemented with a hash array map trie. That is by far the most common implementation strategy, but it isn't at all essential. And, you know, encoding that into the name feels a little bit icky. So I went back to the actual idea. What is this if it's not a hash array map trie? Well, really all it is a persistent, shared, and immutable data structure. So I started to think, how can I put together persistent, immutable, and shared in some combination, and just sort of went through a process of elimination to figure out what names would work. I don't really like PIS as a name. That invokes a different process of elimination. I don't really like PSI as a name because that sounds like pounds per square inch. I don't really like IPS. That sounds like the plural of IP addresses, especially in a programming context. ISP sounds like internet service provider. Spy sounds like something about like observing your code or spying or something. So yeah, that led me, as someone has already guessed in the chat, led me to SIP. So that would get us, instead of list hat, I think it would be SIP list, SIP map, SIP set, or maybe set SIP. I'm not sure about the order there, but so that's my current thinking, but I'm open to ideas either in something along these lines or in a different vein altogether. So yeah, as they say, naming things is one of the two hard problems. VoIP protocol. I haven't heard SIP as a VoIP protocol, so that is one reason to think one strike against that as well. So like I said, naming things is a hard problem. Definitely open to ideas there, and I would be happy to take questions as well. I see in the chat someone saying that there are 3 hard problems because it's off by 1 errors, but that can't be. The joke is that there are 2 hard problems in computer science: cache invalidation, naming things, and off by 1 errors. It doesn't work if you say that there are 3 hard problems, and there's no off by 1 error. Let's see, Dan, it looks like you have your hand up.
I don't have any great ideas for names, but I guess I'm just thinking given that this is based on prior art, Clojure sort of famously has immutable data structures. I've actually used Clojure a bunch, but that was a while ago, and I'm now blanking on what they call them. So, I mean, have you done a survey of the languages that do offer data structures, either built in or as modules, packages, whatever they call them? Is there some sort of consistent name that we can just steal, or is it really all over the board?
It's fairly all over the board, especially languages like Clojure that have them. Like Clojure has these data structures as their base data structures. So they have a list and a vector and a map data structure that, we already have names in. We're already occupying those names. So they don't have them denoted separately, since their built-in data structures are all immutable. And then they have, I believe they have a way to either directly or calling out to Java, I forget. They do have a way to have some specially mutable data structures, but they have sort of an inverted naming convention because they are immutable by default. And there are some languages that have these as libraries. They do tend, I think JavaScript has it as a library, but because JavaScript doesn't have a separate notion of list, they just have arrays. I think they use list to be, much like we do, to be the mutable version. And that would be one option, the sort of name floating around in the list space that we have not already assigned a meaning to is vector. I don't love that, partly because I have spent some time with Rust where vector is the immutable version and array is the mutable version. So something in my brain rebels at the idea of making vector the immutable version, but that would be one option if we wanted to go pick a new name for things. But I'm seeing some chat, no, not vector, which is again kind of my instinct as well. But a broader survey, to your point earlier, Dan, could be a good option. Like I said, I've made a note of a few, but certainly not a comprehensive survey. And let's see, William, you have a question as well?
Yeah, please call me Bill, Daniel.
Bill.
Yeah, you're just going to have to back up a second, explain to me your persistent data structure versus red-black trees, because I always seem to forget this point.
Sure. So a red-black tree is a similar idea in that it's a self-balancing data structure. It's been a while since I've implemented a red-black tree, but that works along similar lines, but the hash array mapped trie backed persistent data structure, it is going to have many more buckets per node and is going to it is going to either hash or use the index value to traverse the tree, and doesn't have any sense of coloring the nodes the way a red-black tree does, and thus doesn't need to rebalance in the same way that a red-black tree does. I'm not sure that was a fully comprehensible explanation, Bill, but I'd be happy to send you a link that compares the two.
Yeah, and that just sort of that's an entree to the question of whether or not you can kind of riff on that design, to use a name. Obviously, RB is not a good acronym, but maybe BR. We get the Brazilian connection going here.
I don't think so, because they are similar enough, but distinct in use cases. my first instinct is that it would confuse people to pull in the idea of red-black trees, because these are trees, but are not red-black trees under the hood. So I think that would risk increasing confusion.
Yeah,
but,
and yeah, sorry, go ahead.
No, I like the way you're thinking. That's a helpful approach to sort of come at it sideways, and I like that. All right, well, I am about at the end of my time, and I don't see any other questions, so I'm going to stop my video at this point and turn it back over to Andrew.
And Andrew said that I could have a moment or two to remind you the lightning talks are coming up in a bit. At this point, there are 6 of them, including 2 videos. So there's room for another one if anyone has one.
Guess that means it's my turn. Hi, everybody. I'm Tony Odell, or Tonio. Probably interacted with you on IRC. And today I'm going to be talking about ecosystems and a little bit about Fez. So I'm going to figure out my screen. Can everybody hear me? Or can anyone hear me? Sweet. Liz says yes. All right. So I'm lazier than other people. So my whole talk is done with BIM slides. We can skip this slide. I already introduced myself. And the Zoom bar is in the way. Okay, so today I'm going to talk about P6C, which was really the first sort of ecosystem that Raku had. That's been around since at least 2009, 2010, when I first got involved with Raku. It's just a list of repositories that contain Raku distributions. The next one is CPAN. We worked on that. during a Perl tool chain summit in Lyon a number of years ago. That one's kind of loosely authenticated and basically just a big file repository. And then Fez, which is fairly recent, that one's been thought about and kind of in the works since we started working on Zeph. If you go through the Zeph commit log, you'll actually see some code that I wrote in 2011, 2012 to try to make a Raku ecosystem start working. But I think within the last couple of years, it's been the right time. Fez was built specifically for Raku's distribution spec, and it's strongly authenticated. Right, so let's talk about P6C first. So P6C, as I said, is just a list of Git repositories. That makes it really easy to decentralize, to mirror the ecosystem, and to do a lot of stuff like that. It's not a lot of work for distribution or module authors to update their module. All they have to do is push their updates to master on Git, and all the behind the scenes stuff that makes that makes P6C work takes care of what it needs to take care of. The cons of P6C are kind of numerous. The top three in my mind is it's very difficult to index. Currently, the way that it gets indexed and your modules actually make their way to the end users is there's a process that UGEXE runs that looks at the list of modules in the GitHub list, fetches all the metadata, and then puts that into basically a big JSON list that can later be consumed by Zeph. It does very little spot checking. You can put whatever you want in the metadata and it gets indexed, as long as, you know, the name and version and all that stuff actually exists, and sometimes not even then. There's no strictness. There's no way to actually verify that that if you want to download a module that I wrote, there's no way to verify that you're actually getting a module that I wrote. Anybody can upload a module with my name on it to Git. And then the other big one is it requires external tooling to get stuff out of Git. There's no over HTTP, just plain text way to get modules out of it. You either require some kind of SSL, you require Git, or some other type of tooling. All right, so that's P6C. CPAN, a lot of people are familiar with CPAN, especially if you come from the Perl world. It was designed for Perl. It's been around for a long time. It's very stable. It has a very simple architecture. It's very easy to mirror CPAN. It's very easy to create private CPANs. There's a tool, I think it's called MI6, module authoring tool, already integrated with CPAN, makes it really easy to upload. And that's a lot of what CPAN has going for it. Like P6C, because it's so simple, it has no auth strictness checks. I could upload a module with Liz's name on it and CPAN doesn't care. The indexers don't care. It'll make that module available for download, even though the auth doesn't match. Dealing with pause is kind of a hassle. That's a common complaint. And just like P6C, CPAN requires post-processing to actually index. It requires something to go through and create a list of the metadata that's actually available to Zeph that Zeph can consume and download the modules. It is a step above P6C in that in order to upload, you do actually have to have authenticated at some point. But again, you're not guaranteed to get the right module. All right. And then Fez. Fez is something that I wrote a couple of years ago. It's been kind of a long process because I have a main job that I do, and this is kind of a hobby. But Fez was designed and spec'd for Raku. I've been involved with the spec for Raku for a long time. I'm fairly familiar with it, although it has changed a number of times. The index is easily consumed by Zeph when you upload a distribution to Fez. That meta automatically gets put into an index that Zeph can just look at and use. It doesn't require Zeph to do any post-processing. It doesn't require a job for Zeph. And the index happens immediately. As soon as your distribution is stored somewhere that Zeph can download it, your module is in the Fez index file. Module publishing is pretty easy to do from the command line. That tool MI6, there's a PR for it to actually integrate with Fez. I'm not sure what the status of that is today, but if you're into authoring tools, check that out. It's a little more involved to mirror than just using rsync, which is what people mirror CPAN with. It's not really too much more involved than using rsync. The main index file for Fez contains where to get all the files from and what their names are. So it's, basically just writing a script. It's still relatively young. There's about 400 modules that are currently uploaded to it. There's, within the first 50 modules, there was a couple of bugs that were found. They were fixed very quickly. And it's been very stable since then. There's no real package browsing website or GUI that's specific to Fez. You can use Raku Land, which indexes all of the Fez files and integrates with it. But there's nowhere like Node has npm.js where you can go look at all the modules that you've uploaded and have made available for people. That is a consideration, but kind of the future, I'm thinking more on making quality indexes for uploaded modules. All right, so that's Fez. I'll show you what the architecture running Fez looks like with my sweet graph here. So I'm going to be talking about this highlighted part. So the Fez CLI, that's where you type, into your command line, Fez upload. When you type Fez upload, it goes to S3, gets an upload link. You upload the distribution to S3, and that kicks off a Lambda, which actually indexes the file. So it looks at your gzip file, looks at the meta JSON file in the gzip file, figures out where it should store that, how it should index it, moves it to where it's going to be stored, and creates a task for the indexer. And the indexer runs as a separate process so that there's no race condition, and we can kind of guarantee that your distribution is going to be indexed. So it's a very simple back end, and it works really well, and it's really fast. So within a couple of minutes of you uploading your distribution, you'll get a notice that it couldn't be indexed for a reason, and that reason will be in the email, or your file or your module will show up in the index file, right? And then on the back end, Zeph can consume that index directly. It doesn't need to cache anything, and it can search and easily download the new modules. So Zeph CLI will go fetch the JSON, do a search in the JSON for it, and then go to S3 storage and download that module directly. Which, if you wanted to mirror the Fez ecosystem, is exactly how you would do it. You would just do it for all modules. All right. And I think my talk is pretty short. I'm not sure what time it is. 10 minutes, yeah. Okay, so that's all of my info. I'm Tony O, or Tony Odell. You can chat with me in IRC. Feel free to PM me. If you'd like to donate to Fez's ecosystem, or the cause or whatever, then you can Patreon or GitHub sponsor or whatever. But that's all I have prepared slide wise and to chat about. So we'll go to questions. I'll stop sharing my screen so I can see stuff. Cool. Looks like there's no questions. Thanks, everybody.
Sorry, quick question. I think there's time, right?
Oh, plenty of time.
It seems like you said you're just storing stuff in S3. It looks like there's sort of a potential, DOS that could happen here. Obviously, if somebody decides to upload a module with a couple dozen copies of Wikipedia, I mean, S3 is pretty cheap, but still, obviously there is a DOS opportunity, vulnerability here. Have you built any protections in? And then you're talking, mentioning, authentication. You can't upload. So there's sort of two separate but related questions. The first one is about the S3 business, and then the next one, the related one, about authentication. So if I try to upload a module with somebody else's metadata, what exactly happens? How is that prevented? Is that allowed, but then Zeph won't show it to me, or will highlight it, or am I not allowed to do that? Yeah, that's sort of the end of that question, I think.
Good questions. On the first one, there are file size limits to what you can upload, so you can't just upload a terabyte file or anything. And yeah, there's some protection built into the endpoints. If you try to hammer that endpoint to upload your distribution, 1,000,000 times a second, it's rate limited. You can only do it once every few seconds. So there's protections built into it that way. On the second question, which was what protections does Fez provide on the metadata? Yeah, that's a really good question. So Fez will take a look at the meta JSON file in whatever you uploaded, if it exists. And it'll do a lot of verification. So there's a key that you use when you upload, and that key has to match a key that was generated for your user when you requested the upload link, right? So if that key doesn't match what it sees in the meta file for your auth username, then Fez rejects it. It doesn't store it. It just basically deletes the gzip file that you uploaded. It doesn't store it anywhere, and then it sends you an email telling you that the auth didn't match. So if my username is Tonio and I upload something as code sections, I'll get an email after it looks at the meta JSON file that says, hey, your auth didn't match. Please try your upload again. And the same is true of other parts of the meta file. If you upload a meta file with an asterisk or a star as the version or API or something like that, Fez will tell you that it doesn't allow that. The reason it doesn't allow that is that it will supersede version matching in some instances and can cause problems down the line. So Fez actually does more strict checking than the other systems, which is to say it does some at all. But it does try to verify that your username matches what's in your meta file. Does that answer your question? Or can I elaborate on something specific that you'd like to know more about? Cool. Yes, Daniel.
So a somewhat related question. I know that one of the problems a lot of other language package managers have had has been with malicious packages. What is the story with Fez for that? If a package is discovered to be mining Bitcoin or harvesting credit card numbers, is there a way to programmatically react and delist a package?
As an end user, not really. I have tools in place that I can use if a package is discovered to be malicious, that I can just remove it from the index and remove that package itself from Fez.
And then mirrors would just pick up that delisting?
Yeah.
Okay. Thanks.
Dan?
Yeah, that actually, Daniel's question, good point. It reminds me of, there's been a whole slew of like papers recently about package, ecosystem, problems of various kinds. Most recently in Python, there was some paper that wasn't actually very great, but nevertheless, this is obviously a big topic. And so what about, for instance, so you mentioned, disallowing the star because, that sort of can win any version checking. But what about the near miss problem? If somebody misspells, a common package, a transposition, an off by one error, or you're reversing, the name is, verb noun, and somebody uploads a package that's noun verb and it's actually, malicious. Again, is there any automated security checking? Is it really just sort of, at this point, it's still, the ecosystem is still so new that it's dependent on people noticing and alerting you. And this is a massively hard problem, so I wouldn't expect to have that there's that every possible vulnerability has been addressed ahead of time. But there has been a lot of research into the kinds of problems that well-established ecosystems experience, and it might be good to look at some of those that work and see what can be done preemptively.
Yeah, there's not a lot going on the Fez backend to make sure that off by one package names are not made available immediately, and there's no manual vetting process that is in place at the moment. But yeah, now's the time. I could always use help figuring that stuff out. But I haven't seen that problem come up in the Raku module system yet. There is an idea that I've been working on that would do a little bit, maybe not on the misspelled name, but if somebody's uploading modules that mine Bitcoin or do something like that. And that project is basically doing regression and quality testing of modules. And I think what you're talking about comes into play a lot with what is the quality of a module? How well is it tested? Does it work on many operating systems? Does it not work on specific ones? And making that quality score available for modules is probably my next step in developing Fez.
I assume this is sort of similar to CPAN testers.
Yes, it's fairly similar to CPAN testers. The idea that I have is I'm only superficially familiar with CPAN testers. If I remember correctly, CPAN testers gets data from the outside world. The way that I want to do the quality testing is on VMs and developing that quality score internally, and then allowing external factors to also come into play. So data from external people.
I guess sort of, I hadn't really thought about it, but you just mentioned, along with the quality, what about, using something like, do you have any interest or any plans to integrate with something like Blinn, which, sort of the automated, the test tool that automatically tries to like install all of the modules, and if something fails, it bisects Rakudo to see where the fail happened. That seems like maybe there's some interesting integration that could happen, with the ecosystem where somebody uploads a module and, well, obviously hopefully it works right away, but maybe you test it with old versions of Rakudo, on upload. Does it install if you're using Rakudo's back through X number of releases, and that might be part of the quality score.
Yeah, so the plan there is to cycle through VMs running OS X, Windows, various flavors of Unix and Linux, and doing something very similar to what Blinn does to generate that quality score.
Cool.
I need more time in a day. Does that answer your questions?
Yeah, good.
Okay. My old friend Stefan.
Hey, Tony, great to see
How's
you
it going?
again. A follow-up question on the authentication of users or authors, really. So Fast does the checking with the Meta6 JSON files, which is what it does different from the community or the CPAN ecosystems. But what do we really gain as long as those ecosystems are still there? I can maliciously upload a distribution under a different author's name, and Ceph will happily install it.
Yeah, that's true. I think the direction that I personally would like to see it go and would like to take Zeph in is to phase out P6C, which is obviously a big undertaking. A lot of stuff relies on modules that are only available in P6C. JJ Atria's talk, he mentioned the complexity of deduplicating modules between ecosystems, or having modules that the author has moved on to something else, to woodworking or whatever, and no longer maintains. PRs aren't being accepted, but something relies upon it. So it's really hard to get rid of P6C. It's really hard to get rid of CPAN. There is a strong relationship between Raku and Perl, as much as some people would like that not to be. But I think I would like to see the direction move away from P6C and move away from CPAN, and start to use things where you have some reasonable assurance that the author you're getting the module from is the author that actually uploaded it. So there's no immediate benefit to Fez's strict auth checking, but I think down the line there is some security in it.
Would there be some middle ground by kind of intentionally confusing the content storage services like CPAN with authentication? For example, if I state in my Meta6 JSON that the author is CPAN 9, which is my handle on CPAN, and Ceph could check that, then we would have authentication. Because Ceph knows where it got the dist from, and it can check that it actually downloaded it from my user account on CPAN.
Yeah, that makes it really difficult to mirror CPAN or use a private private pan, because now you're, if you're using cpan as the URL and that's how you're figuring out you're getting it from cpan, then it removes the simplicity of cpan itself, which is just a big file repository. So yeah, you could do stricter auth checking against cpan, or you could also make the indexer that trolls cpan, make it only index files where the user who uploaded it matches the meta username. But again, you're still relying on a lot of back-end processes that have to happen before it actually works for Zeph. And you can't guarantee that the indexer wasn't compromised either in that case. How about Raku community modules? I don't know. I don't really have an answer for that one. One option is to create a Raku community module account where many people have access to it. Yeah, there are a number of options there. It could be automatically indexed as a special process. In Fez, yeah, we should probably chat about that offline, Liz. Come up with an answer to how that'll work. Or somebody can just own the Raku community modules and they can be responsible for uploading them. But that doesn't seem like a great option either. I think I'm over time. We did it. Thanks for all the questions. Introduce group concept in Fezza. Yeah, that's a good step also. I need to prioritize some stuff. The group concepts would be pretty great. Oh yeah, okay. I'm getting kicked off. Thanks, everybody.
Grammars are one of my favorite Raku features, and when I'm working with them, I enjoy using the comma grammar preview. This shows me how far my grammar got matching the text that I gave it. I can then edit the text and see the updated result. Double-clicking on part of the text will show me exactly which rule matched it. I can also see places my grammar backtracked, which might give me opportunities to improve its performance. Choosing an element or a match in the grammar takes me to the bit of the text that it matched.
Okay, so hopefully the screen sharing is working nicely again, and you can hear me. Yay, you can hear me. Excellent. Thank you. Okay, so this is my second talk, which is going to be about the general dispatch mechanism that I've been putting into MoreVM. And I hope you're looking forward to seeing code in multiple different languages during this talk. But yeah, that's, we're going to be having a nice dig all the way down into the runtime today. So this is what I'm going to cover. First of all, you might be thinking, what on earth is dispatch? What is a dispatcher? Why do we care? So let's start there. Then I'll talk about the current approach that is taken and the sort of shortcomings and limitations of that. And then I'll talk about the new approach that we're taking to dispatch and implementing lots of Raku features which fall under the heading of dispatch. I'll then show some current results and talk about the current status and how long until this is shipped, and some future opportunities for improvements as well. So, what even is this? What is dispatch? Dispatch is kind of the thing that's everywhere and nowhere. So, if I have an object and I call a method on it, somehow we end up running the appropriate method. And this all feels pretty natural in a way, but there's actually quite a bit of mechanics that might be going on to make that happen, particularly in a language where we can do custom meta programming and actually customize what method lookup means. Multiple dispatch is also everywhere in Raku. When you add two numbers together, we don't, at least in the abstract, know the types of the two things that we're adding. And so we have to do a multiple dispatch. So the types of all the arguments work. And then we end up in the appropriate candidate. And that's an even more involved process than method dispatch. And of course, we have multi-methods, which means that we have the two of them together. So dispatch is really the thing that sits between the places in our code. It's how we get from place to place, and we kind of, despite it being everywhere, prefer not to actually see it. Especially, we don't like it when we're writing code that is doing the work, and then we profile, and then we discover that actually the runtime is spending a lot of its time figuring out where on earth to go in order to run the code, and that can sometimes happen. Particularly if you do multi-dispatches today with lots of where clauses and things like that, you can quite easily find that a lot of the runtime is spent effectively on dispatch, on figuring out which candidates to run, and it can be pretty high. Actually, though, I've come to realize that while there's things that we traditionally would call dispatch, like method dispatch, multiple dispatch, and so forth, really, you can see it in a very general sense. Dispatch is any process where we have a bunch of arguments and we consider the types or maybe even values of some of them, and that leads to a decision about what code we run. And that sounds incredibly general. And the nice thing is that if we actually embrace that genericity, we can come up with a mechanism that solves a lot of different kinds of dispatch problems. So assignment is a dispatch. We don't really maybe even think about it as one always, but it is. And what an assignment does is actually very, very variable. Pun intended, not intended, but it was good. Okay, so the first example here, we have an untyped scalar. And a scalar is an object, it has a value attribute. And when you do an assignment, it's just binding into that value attribute. If it's an untyped scalar, that's all we need to do. If it's typed, however, the behavior is a bit different. We need to do a type check on the thing that we're assigning. If we assign nil, it's different again. It doesn't matter whether the container is typed or untyped or defaulted. We need to find that default and reset it back to that, and the nil itself is discarded. And if we have a hash and the hash doesn't contain that key yet, then we need to vivify it. That's a lot of different things going on. Interestingly, of course, in any given assignment that we look at in the program, it's probably only doing one of these most of the time. It's quite unusual to end up with actual polymorphism here, but it's still there's a lot of semantics there, and the decision is all based on the arguments to the dispatch. In fact, I went through and tried to make a list of things in Raku that are dispatch, and I suspect this is incomplete, but there's actually quite a lot of things in here. So there's lots of different types of method call. There's the normal ones, the maybe method calls, the qualified method calls in a role, normally when you want to say which role's method to go to solve a conflict. We have multiple dispatch, which is incredibly involved. We have the call same and next with, which means go to the next candidate of the dispatch, which is actually very context sensitive because it depends what sort of dispatch we're doing. We have wraps, which, you know, we wrap some code around something and then we have to move through those. Coercions, have to decide what kind of coercion thing to call. We have return type and bind type assertions. You might think, is return type checking really a dispatch? And the answer is yes, it is, because in the case where it's successful, it's the identity function. In the case where it's wrong, then it's something that throws an exception. So all of these things are really cases of dispatch where we make a decision primarily based on arguments and types, and they intersect. So you might have a call to a method, and you call a multi-candidate, and that particular multi-candidate has been wrapped, and then you do a call same, and you know you'll probably go through the wrappers, and then the multi-candidates, and then the methods. So the amount of semantics in this is mildly terrifying, and I've actually spent the last months dealing with all of them. So how have we tackled this to date? And what are the problems with that, and why have I made this the thing that I've been concentrating on for the better part of the last year, on and off? Well, let's go back all the way to the beginning, and not really the beginning of Raku, but at least the beginning of MoreVM. And MoreVM is the virtual machine that Raku is mostly ran on these days. And when I started out MoreVM, it was something that looked a lot like this. It was we might say, a naive interpreter of bytecode. And you have, this is macroed all over the place. So it's C, but it's good at disguising itself. It's done like this because some compilers can do computed goto and some don't. Don't worry about that. But the principle here is that we basically branch over the instruction that we're meant to execute. We execute it. MoreVM is a register machine, so if you look at that add I instruction there, then it puts into the target register the result of adding the values from two source registers. And you can see we have conditionals, which if they have a bytecode position, when the condition is successful, then we jump to that location, and so on and so forth. So of course you have a lot of overhead there for dispatching each operand. And so when you're at this point, and this is how we started, you know, you say, well, interpreting bytecode is pretty slow, but C is pretty darn fast. So obviously the thing that we should do is write the performance critical parts in C. So you look at the things that are really, really common, and you write C code for them. So you end up with some quite complex ops. For example, there's a find method op in MoreVM today, and it's implemented like this. It retrieves the object, it retrieves the register that we're going to put the found method in, it takes a method name, and it goes to find it. Now, first thing it tries is to look the method up in a cache. And the cache is actually, in the current implementation, pre-computed. It's just a huge hash of all the methods on that type, including the ones from the base classes. And if that doesn't work out, then it actually has to call the find method on the meta object. And if you think about that, that means that to find a method, we might actually also have to find a method. And there's a nasty little restriction in MoreVM today, which I don't think anyone has managed to run into yet. But someone will probably correct me on that. That if you do a find method and then you have a meta object, that meta object's find method has to be in the cache. I'm getting really confused trying to even say this. And it gets worse, because if we call a find method to find a method, that can be written in Raku. So the whole process of doing the method lookup is actually, there's some stages there. And when you start doing these things, and you're in a virtual machine that has to support continuations, which is the magic between gather take and await async, you end up having to write C code in continuation passing style. And that is just like the thing in JavaScript or Node.js before they had async await, where everything is callbacks everywhere. And so an amount of more VM ended up looking like that. And it's even more fun when you don't have garbage collection. And it's even more fun when you're in more VM and you have garbage collection, but only for some of the things, and you have to be really careful which ones. I think I might have convinced you that this is kind of complex and not necessarily in a way that is conducive to being reliable and robust. Of course, we put a lot of engineering into this, so it is pretty fine, but it's kind of tricky. Booleanification. So if every time you do an if in Raku and we don't know it's a native type, this opcode in the bytecode interpreter is what interprets it, and it calls this thing called isTrue. And the reason that we do this is because in a lot of common cases, we really want to try and avoid calling the bool method, because method calls could be pretty expensive. So we sort of have a switch statement here which tries to work out what sort of type it is, and if it's some kind of special type it can cheat on, rather than actually calling the bool method on it. And you might say, well, it's another switch statement to decide what to do, but it's C, so it's fast, and it's faster than the whole bytecode interpreting, and it's definitely faster than method calls. So this seems an okay trade-off. And all of this made sense in, I guess, 2013. With time, it's started to make less and less sense. And that's because more VM has been learning. It's a very different machine than it was when it started out. It can do all of these things. It can do type specialization. So when it interprets a program, it looks at what types really show up, and then it produces optimized versions of the program for those. So it doesn't just run your code, it actually rewrites your code for the situation that really occurs. And it can even do that speculatively. So if it says, the statistics say that 99% of the time this thing is an int, it can optimize the code for that case. And if it goes wrong, it can say, well, it went wrong, so let's undo all the optimization and fall back to running the original code. So behind the scenes, the virtual machine is actually flipping between optimized and unoptimized, potentially thousands and thousands of times a second. We of course prefer it to stay in the optimized ones, but it's actually strategic to leave slow paths out of optimized code sometimes. Inlining. So we copy small routines into the routines that call them. So all those bool methods which don't do a lot, we can get rid of all the calling overhead of them. This is really important in Raku because even adding two numbers together is a multiple dispatch. If you actually go and do all the calculation and you do all of the calls to those, it's really, really slow. So we rely heavily on these sorts of things. And then that interpreter, which does the whole the switch statement thing, or the computed goto, we can get rid of that overhead because we can convert the bytecode into machine code, and then the CPU just chugs through it. These things change everything. At first we only had a bytecode interpreter, but now we can JIT compile it into machine code. Before, lots of little method calls were really expensive, and you did some tricks to avoid them. But now we can just inline them, and the cost is kind of gone. And that in the past, doing the hot things in C was kind of a clear win. But nowadays it's really not, because the C code is just this opaque blob of stuff that we can't see inside, and so we can't use all the type information that we've gathered to optimize. It's actually worse for us that things are in C for fastpaths now. That doesn't mean it was a mistake to build the VM that way in the first place. We didn't immediately go and have the budget to go and build a VM doing all of these different things, but with time we have built them, and we're in a very different place. One of the other things is that only some kinds of dispatch got special treatment in the runtime. This is actually a really nice place. This is where I'm going on vacation next week, and the reason that I put it in here is not just to make me happy thinking about that, but actually because I want to talk about performance cliffs. And a performance cliff is something where we have a bunch of things that are pretty fast, and we write programs using them, and then we have some other language features, and if we use them, we fall off the performance cliff, and suddenly things are really, really very slow indeed. And yeah, this is a partial list of course of these things, but if you just do simple multiple dispatches, or you do method calls, or you put things in Boolean contexts, this is all decently fast today. But if you do a multi-dispatch and you data write a where clause, or you decide to use call same, that is a real huge slowdown today. The qualified method calls and maybe method calls used to be the same kind of painful. They're actually somewhat better now in master because of an intermediate solution on the way to the new mechanism that I'm talking about today. But they're still not really ideal. And the sort of rule here is that if you have something that's a dispatch, and the runtime, the virtual machine, and especially its optimizer, doesn't really understand it as a dispatch, it's probably going to be really slow. And you might say, why is that? And really, it's because there's a lot of costs that are there, but they're not immediately obvious. If we implement the maybe method call like this is the original implementation of the dot question mark operator. It actually compiled into a call like this one below. It called this dispatch dot question mark method. It passed the invocant, it passed the method name, and then the rest of the arguments were slurped up. And then it checked if the method was there. It called the method, and you kind of look at that and like, well, there's some cost in there, but what makes it really bad? And the thing that really hurts in an optimizing virtual machine like MoreVM is that it turns what I call mild polymorphism into megamorphism. What do I mean by that? Well, this is a measure of how many different places might this call go. So at a given location in the program, logically that dot question mark, depending on the type of object, in the really lucky case, we always get the same type there, and it always either has the method or doesn't have the method. We call that monomorphic because there's only one possible destination. If it just goes to a few different places, we'd say that's polymorphic. So sometimes the method is there, sometimes it's the type where it's not. And then there's this situation called megamorphism. And megamorphism means that there's loads and loads of possible places that it could go. Now, when you're specializing code for particular types, monomorphic or likely polymorphic things play really well with that, because you produce a version of this code at the top, which is compiled for a particular type, and that type either always has the method or never has the method. And so you end up being able to completely eliminate the check of if the method is there, and maybe even inline it, or just turn it into nil if it's not there, and then there's no call at all, it's just a constant. But if you have some point in the program like this below where they all congregate and all of the calls end up there, it ends up megamorphic, and there's not really much we can do about that. So, one name handful of types, many names, many types. Very, very different situation for the optimizer. And every time that we don't really have a mechanism to express the dispatch to the runtime, we end up in that second situation, and it ends up not being able to do a very good job of the optimization for us. So really, optimization is very heavily reliant on turning potentially polymorphic programs into mostly monomorphic programs. Now, of course, there's an even worse thing here, which is that we slurp all of the things there, we flatten them there. That's also pretty slow. So yeah, this is a lost opportunity as well. Actually, in current Rakudo, if you call something with flattening arguments, a whole bunch of caching of dispatch lookups and things don't really work out, and you lose a bunch of performance on that too. So there's so many reasons why that's bad. So you say, oh, what can we do about this? And one thing you might think is, well, let's just teach the virtual machine about more language features, and then it will do a better job at all of them. But it's not that easy. You know, we already know that we're beyond the point where writing hot path code in a C function is not actually going to help us. The type specializer can't see into it, so it really wants to see bytecode and inline caches and other things that it can talk about. The other thing is that it's actually really hard to write these things correctly in C once they get complicated. And a bunch of the orchestration of dispatches in Raku are really very complicated indeed. Yeah, it's only a small slip up to get a garbage collection bug or something into there. So I really would like to be writing a lot less C to actually make these things faster. The other thing is that if we want to have new language features and they involve some kind of dispatch, modifying the VM is quite a restrictive way to do it in terms of, you know, who has the background to do so. Whereas if we have something that's a little bit more general that we can configure and tell about new dispatches, then in theory, it's much easier to get new features in and get them performing. So I've adopted a more sort of generalized approach now. We have one new instruction. It's called dispatch. It's exposed like all of the other virtual machine ops. We expose them via an NQP : syntax. You can't write this directly in your Raku programs without the pragma, but this is a call down to something provided by the runtime. So here are two examples of using this. So the dispatch op takes a dispatcher ID and 0 or more arguments. And you might be looking at this and saying, congrats, Jonathan, after all these years, you've learned to implement the identity function. And yeah, they look rather like that. But actually, if we write this, then we can see a difference. So here I am using the new dispatch mechanism. I'm calling a dispatcher with the name boot value and giving it an argument. And then I'm calling another dispatcher called boot constant and giving it an argument. And we can see that boot value really is the identity function, and boot constant is something that just remembers the first value that it saw and always evaluates to that in the future, regardless of the thing that it's given. So you might think, there's some kind of cache going on here. How does this actually work? And to find that out, we'll take a look at the bytecode. And the bytecode is essentially the assembly of the more VM virtual machine. And it looks like this. And the things to spot in here are the two dispatch ops. But actually, if we look closely at that, we'll notice that there's other dispatch things as well. There's this one here, which corresponds to calling the say function. That is a lang call dispatch. And this is NQP code, the small restricted Raku subset we use to implement the compiler. And the concatenation operator here needs to turn values into strings, and that also now is done using a dispatch. And the dispatcher there is called NQP stringify. It would look like we've been kind of successful in making the dispatch mechanism general, because apparently half of the program now is dispatch ops. Now, what actually happens when the virtual machine sees these? Well, the very first time we run this function, it goes through a process called bytecode validation, where it checks there's no like go-tos out of bounds or any other weird invalid things. And for every dispatch op, it allocates a piece of storage. And into that storage, it sets a pointer to a singleton object, which is an unlinked state. When we run the dispatch op, it does this. And don't worry about all the details of this, but we'll walk through the steps. First, it finds the location of the current state. And by the current state, I mean the slot that we allocated for the dispatch instruction. It then says, okay, what is the current state? So it dereferences it to see what sort of result we have there now. We then look up the ID of the dispatcher, what sort of dispatch we're doing. We look up the call site, which is the tells about the number of arguments that are getting passed, and if any of them are named arguments. We locate the arguments to the dispatch. We do a bunch of setup work for the return value. Don't worry about that. And then the really important piece is here. That's the ICE, which is short for inline cache entry, is then run. We have a run dispatch function on it, and this does whatever the right thing is. Now, the right thing in the unlinked state is to record a dispatch program. When we do this, we have the boot value is one of the things built into the virtual machine, and it produces a little program like this. And it says load argument 0 into temporary 0, and then set the result value from that temporary. So basically just copy the input into the output. Boot constant looks a bit different. It says, well, we have a table of constants with this program. Just load the first one, the 0th one here, and then use that as the result. Boot constant and boot value are two things that I call dispatch terminals. They're things that produce a final outcome, whether that's handing back a result or, as we'll see in a moment, running some code. So this is another dispatch terminal. This is the way, with the new dispatch mechanism, that we actually make bytecode run. We call boot code, we give it the piece of code, and we give it the arguments. And again, this is the way that we're running things. There's another one called boot syscall. Boot syscall is calling functionality built in to the virtual machine. So there's a built-in called LMs, which gets the number of elements in an array. And we can just call that using the syscall mechanism. That's another terminal, another thing that results in an action being taken. It turns out that these 4 are enough for everything. Basically, produce a value based upon an input, produce a value and it's a constant, run some bytecode, or run something built into the VM. Everything else that is built on top of this is built as something in terms of these 4. And that pleases me, because we've got something at the core that's fairly small. I see someone asked a question, which then disappeared. Okay, I'll answer the question later. Well, I don't know how Zoom works. Okay, so that's all we need. So then you might say, but that's a pretty big gap from doing all of the fancy semantics of the Raku language. So all of the fancy stuff happens because we can declare dispatchers in what I call user space. And by this I mean dispatchers that we write using a high-level language, and they're all at the moment implemented using NQP. So you use the boot syscall mechanism to register a new dispatcher. I'm calling this one identity for reasons that will become obvious very soon. And this gets invoked with a capture object, which represents the arguments to the dispatch. Every user-defined dispatcher should ultimately delegate to some other dispatcher. And in this case, I'm just going to delegate to boot value. So you can see I'm doing a boot syscall. I'm saying the syscall is dispatcher delegate. Then it has boot value there, which is the name of the dispatcher I want to delegate to next. And I'm just passing the capture along. And boot value is the identity function. So all I've done here is wrapped up the identity function in another dispatcher. And yeah, that's not very useful yet. That's how we call it, by the way. So if you do an NQP dispatch after registering this, we can already use that dispatcher straight away. Here's where things get more interesting. We can do transforms on the capture. So for example, if you look at the bottom of this first, I have a dispatch to drop first, and I'm passing the code. I'm passing a 1 and a 2. And that piece of code takes only one argument. In the dispatcher, we take the capture and we say dispatcher drop arg, and we get another capture back, which represents the original one, but with argument number 1 missing. Remember, argument 0 is the code to run, and argument 2 is, in this case, the number 2. And then we delegate to boot code, and we end up with the invocation. What about this one? So this is called type name. This is a dispatcher that will map a type, well, an object into the name of its type. So this is a little bit more involved. That NQP capture possarg extracts the argument value from the capture. And then we are going to ask for its name. And then we're going to take our call site and we're going to insert a literal string as the 0th argument. And then we will delegate to boot constant. Now, boot constant ignores everything except the first argument. Boot value does as well. So inserting something at 0, it just means throw away the rest if we give it to one of these two. So we've got something which hands back type name. Does it work? No. And what happens in here is we call try it, we pass in the badger. In here, it gets the badger, it gets the type name, it inserts the string badger, and it sets it as a constant. That is the recorded dispatch program. The next time we hit it, we say, we already have a dispatch program here. So we run it and we produce badger. And yeah, we never get our mushroom out. And that's a problem. So how do we fix that? Well, the other important piece of dispatchers is guards. And here we take the capture, we say, I want to track the 0th argument, and then we send it into a guard function. And what this means is this dispatch program is only valid if the type matches the one we observed when recording it. And that is enough to fix it. Now, you might be looking at this thinking, this all looks very expensive because we are dealing with all these captures and we inserting guards, we're delegating between dispatchers. But when we end up with the final dispatch program that we actually install at the call site, despite all of that going on and shuffling around of things, the dispatch program erases it all. There's no trace left of the delegation. There's no trace left of all the intermediate capture objects and tracking objects. It's just a free instruction dispatch program, which is check that the type is badger. If it is, grab the constant from the constant table and use it as the result. So what's happening with the call site is it starts in the unlinked state. We record the dispatch program and it moves to the monomorphic state. And for the next calls where we pass in a badger, it stays there. Then when we pass in the mushroom, it records another dispatch program. And then the state moves to polymorphic, which means there's a list of different dispatch programs that we all consider one by one until we see the matching one. This is a real example. And I won't go into every little detail of it, but this is how NQP resolves method calls. So we try to find the method. So we're just extracting the invocant, the first argument. We're finding the method name, and we're calling find method. And by the way, that restriction I mentioned before with caching the find method is all gone now. If there's a method, we say, well, it's only valid to assume this is the method result if the type is the one we saw and the method name is the one we saw. Of course, most method names are actually constants, so that check is free. It can see that it doesn't need to do that. We tell it to do it in case it's a method dispatch that depends on the name, but most of the time that ends up as a free check. And then we say, okay, take away the method name and invocant, insert the resolved method, and then delegate to something which will actually invoke it. And that thing is called lang call. And the reason is that this might be an NQP object, but they can get subclassed in Raku, and we need to do the right thing, depending on the type of code it is. Everything else is built out of these building blocks. So in Raku, we have a similar one. The only big difference in Raku is that we support resumption. And resumption is the thing behind call same and next with and going faster with multis with where. And the idea is that when we do a dispatch, we can indicate what information we might need later on. So when we call a method, we can say, well, originally we had this type and this name, and we might need them later. In the best case, there's zero runtime cost for that. That's actually the common case. There's no cost for that at all. It's only if we actually use call same that we go back and say, well, we need to know what the original method and the original arguments were, so we can figure out what method to go to next. And that is how we end up being able to do much better at those features. How the resumption works is a talk in itself, so yeah, we won't go there today. Now, where this then gets really interesting is that dispatch programs that we've recorded and put at the call site are available to the optimizer. And the optimizer can look at them and it can say, well, now I know where this program tends to go at this point. And then it can do all of the nice things that it knows how to do. It can inline things. It can say, oh, I already proved that this thing is this type earlier by doing data flow analysis, so I can throw away this type check. And once it's got rid of probably quite a few pieces of this, it says, oh, okay, we'll JIT compile what remains and get rid of the interpretation overhead of the program and also of these little dispatch programs. So all of this is actually carefully engineered so that it is giving the optimizer exactly the sorts of things that it wants in order to do a good job. So the question is, how good a job is any of this doing? Well, first of all, this is very much something that's been a very active work in progress of late. As of a few weeks ago, this number would have been a lot smaller. But at the moment, the new dispatcher with Rakudo running on it passes 99.6% of the test suite. That's pretty close. We're down to, like, you can count the failures on your fingers. We've got about 40 ecosystem modules that we need to have a look at to figure out, you know, why we might have regressed those. So in terms of it being correct, you know, it's doing pretty well. What is still in progress is getting it all reintegrated back into the optimizers, so that it uses all of this information to do the optimizations. And quite a bit of that is still to go. So, you know, a lot is done, but there's a few really important bits missing. So for cases like, you know, method dispatch and multi-dispatch, at the moment, it's actually slower because we haven't reinstated those bits yet. What we could sort of measure, though, is, well, there's two things. The first one is, what happens if we disable the optimizer? Is it competitive then? And the answer is yes. This first one, method calls, is just a loop doing method calls. Now, if the optimizer knows about this, and once the optimizer knows about this, it actually turns it into an empty loop. At the moment, that doesn't happen. If we disable the optimizer, though, we can see that it's actually a little bit faster at doing this empty method calls. The one that surprised me a bit was this one, the multiple dispatch result, because we've actually gone from using a cache that was specially implemented for multiple dispatches to using a completely general purpose mechanism for all dispatches, and we still win anyway. I'm pleased about this. I'm also slightly, you know, surprised that this has immediately been achieved when there's still things that we can do. You know, that's competitive, but there's actually still more to go in terms of improving the baseline even before all the optimizer stuff kicks in. Baseline, by the way, is sort of important because while it's true that optimizing the hot parts of the program is really important for performance, getting through the cold parts that you only run a few times quicker is also quite good as well, especially at startup time. And yeah, as I mentioned, this is a result that was a bit better than I expected. So I'm relieved about that one. The other thing that we might ask is, well, UDisp was aimed at trying to speed up a bunch of things that are really bad on the master branch. Is the new design good enough that even without the complete optimizer integration, it can show an improvement already? So, you know, if we run some benchmarks with UDisp not completed with the optimizer, and we run Rakudo master with the optimizer doing as good a job as it can, who will win? And the answer for the three things I tested is UDisp, and already by quite a margin. So this first example is a multiple dispatch or where clause. And yeah, it's a factor of 3, maybe 4 already. And that is going to improve further. I mean, it's not actually succeeding at inlining that multiplication operator on UDisp at the moment. Once it does, that will be a huge improvement already over what it's doing now. In fact, probably all of this can get inlined, both of the calls eventually. This is just doing loads of call sames. Call same is really very costly on master, to the point that in places where you might use it, you sort of avoid it if you can. You might say, I don't use call same in my code. How does this help me? The answer is that a lot of things actually use it behind the scenes. If you're using Crow depends on a module called OO monitors. OO monitors uses call same. Call me also on master goes through some amount of contortions. In newDisp, we just basically rewrite the dispatch to call that method instead. And this one, when we're fully set up with the optimizer, will just turn into an empty loop as well. So yeah, there's some work to go before we merge this back, and these ones are all coming out much, much better, which is nice because this is the one of the primary goals was to improve the performance of these kinds of features. There's a few future opportunities for improvement. Of course, the first thing is get it good enough to merge. So this isn't going to happen in August, primarily because I'm going on holiday tomorrow for 2 weeks. But I'm kind of optimistic that we might land this in September. So that would be nice. Once we've shipped it, there's more to do. So in the initial merge we do, dispatch resumptions will not be something that we especially teach the optimizer about. But we'll get there. When we do, then we might start getting to a point where you can write your factorial with where clauses, and it's kind of competitive with just writing it with conditions. Call same, the same kind of story. One other thing that would be really good to integrate with this as well is native calling, because that will get all of our various bindings for databases and other C libraries to be much more performant as well. At the moment, there's various bits of transformations that go on before we actually hit the point of doing the C call, and those could mostly be expressed as dispatch programs. And then if we have a new dispatch terminal, which invokes a C function using native call, that should in theory be quite a lot faster. And then we can get the JIT compiler involved, and I think we can finally realize the goal of having the JIT compiler basically read directly out of more VM registers and call the C function straight in line without any messing around. So that could maybe be a really nice improvement too. And there's lots more. There's lots of little things which today are not so performant that we can tweak and get going a lot faster with the new dispatcher. We might also be able to expose some things we don't have today. Crow request routing today actually checks the signature of a root will match and then invokes it. And there's not a reliable way to just invoke it and find out if it was the thing that failed. And yeah, we can actually maybe expose a call if it binds and enjoy faster request routing there as well in the future, and for anything else that does that kind of design pattern. So I have easily used up all of my time. So I'm not really sure I have time for questions. I see. Vadim commented, at some point more VM will try to optimize dispatching programs. The thing is that actually, yes, because you make all of these boot sys calls, it already actually is optimizing the things that produce the dispatch programs. So yeah, that's way ahead. And yeah, there's no more time. So thank you very much. Sorry for going a little bit over. And I wish you to enjoy the lightning talks.
Comma includes a number of features aimed at developers building web applications using Crow. This includes a number of project templates to get started quickly and easily. There's also syntax highlighting of Crow templates and code navigation between different elements in your templates. All routes are indexed, so it's easy to find out where the code for a given HTTP route is in the application.
It's almost lightning talk time. I'm trying to figure out how to add co-power to our two speakers. I guess you're going to have to do that, Andre. You let Alexey and Fritz in. Okay, so Fritz did it. And Alexey, can you share your screen?
Do you want me to share my screen?
If you can.
Oh, let me try.
And
So,
Andrew, can you give him co-power, co-host power?
so let me see. So share content. Should I start video? So website URL. Okay, let me see. So it's really weird. So whiteboard photos. Can I rejoin using a different device? And
you're a co-host
probably
now.
my iPad. Yeah. I'm saying let me rejoin from another device because looks like my iPad is too old to share. Sorry.
Okay.
Just a few seconds. Sorry. Yeah, I'll be
While
back.
you work on that, I will go ahead and explain what's about to happen. We're going to play by slightly modified the Perl Conference rules. We have one speaker, Fritz, who's going to go first, and then there will be a short gap where somebody can give an ad if you have anything you need to advertise, some project or anything you're working on. And then we will go to Alexey, who has 2 lightning talks. I'll go on him after the first one, and when he finishes his second one, we'll have another switch. And at that point, if anyone has an advertisement, just raise your hand and we'll get you turn you unmuted so you can speak. And then we have 2 videos, and then Andrew is going to give his talk, and then we'll have a chance, one last shot for an advertisement if anyone has one, and then he will finish up the day for the conference. That's where we're going. The other bit that we need to know is there are only 6 of us. We have about an hour, so I can be slightly generous, but at about 4 minutes, we will hear the bell. Did everyone hear that? Good. And then, of course, at about 5 minutes, the gong. Alexey managed to make it back yet? There he is.
I'm here now.
Getting you the power, hopefully.
Yeah, let me check if I can share my screen.
Okay.
Let me check. So, camera. It's Microsoft Google Drive for the web URL. Okay. Okay, let me see 1 sec.
Something happened. Your picture went away.
Yeah. I know that. So just a moment.
Oh, and one other thing while we're waiting for him to get ready is if you do give an advertisement or you're a speaker, when the person before you finishes talking, wait a few seconds. In the event that the YouTube videos get sliced and diced later, it will be easier to slice things apart if you've left a little bit of a gap in between.
Okay.
Okay, you've shared your screen. We're good, so unshare. I will say hello, and then we will get started. So, unshare your screen.
Well, give me a sec.
Okay.
Sorry. Yeah, I just trying to understand how to do this because.
There
okay.
You go.
Okay.
Okay. So let's get started. Welcome
Okay.
to the Lightning Talks here at the Raku Conference, even if I'm wearing an old shirt. A very old shirt, but that's unimportant right now. So we have 6 Lightning Talks coming up. We will have advertisements in between speakers. If you have an advertisement, use the raise hand feature in Zoom, and we will unmute your mic and you can say what you got to say while somebody is getting their slides shared. We have about 4 minutes. Gongs and bells will be coming, and that should do it. So Fritz, go ahead and share your slides whenever you're ready.
Okay, hi everybody. I'm going to talk about Christmas, although the weather isn't quite like that right now here in Switzerland. The talk is about a program which simulates ammonia emissions from agriculture. I'm not going to explain all the details about that. You can, I'll give you some links at the end, which you can follow if you are interested. The common simulation model is used for simulating ammonia production from livestock and emissions from the housing, storage, manual slurry application to the field, and also additional fertilizers for plant production. This amount of ammonia which is emitted by the farms is dependent on many farm-specific parameters. For example, the way the slurry is actually applied to the field. In the left picture, you see a lot of slurry going into the air, and ammonia will be emitted directly into the surrounding air. Whereas in this case, the slurry is applied directly into the ground, and so a lot less ammonia is lost here. Our common application is a single-page web application to simulate individual farms or do regional simulations from statistical data. There's also a command line application, which is used by scientists at Swiss universities to do national projections, running thousands of individual farms at a time and post-processing the results. And just recently, we added a public REST API, which allows us to integrate the simulation engine into other applications. The Acromon program was actually started in 2007 and then implemented in Perl 5 using Motionlicious as a web backend. We had various extensions going up to version 5.x, and in 2017 we decided to refactor the backend and chose Perl 6 and Grow for that. Most of the backend work was actually done by Jonathan. In the 2018 Swiss Perl workshop, we demoed a Perl 6 backend and predicted that it will be online by Christmas 2018, probably. We got easily distracted, and Perl 6 became Raku. And so I wrote an article for the Advent Calendar 2020, Raku in the Wild, which mentioned that there was a test version online and that we will be in production by early 2021. Christmas 2021 happened on June 1st. Acromon 6 went into production. Version 4 and 5 are still online for comparison, and they give identical simulation results if you use the same simulation model and also input data. And those are the links if you are interested in more details about that. And that's it already.
Okay, Alexey, set up your slides. Does anybody have an advertisement? Raise your hand so we can see you. You begin when ready. Oh, there was more slide before.
Sorry, can I go ahead?
Yep, whenever you're ready.
Okay, I'm ready. Okay, so can I get started?
Go ahead.
Okay, thank you. So I have 5 minutes to talk about Sparrow. Well, Sparrow in a nutshell is an automation tool written in Raku. It allows one to write various scripts using various languages, but glue all of them together in high-level Raku scenarios, and also to run the same scripts as a command line tasks. So I'm going to give you a practical example of how to use Sparrow in Bash together, or Sparrow and Raku together. So first of all, we need to install Sparrow, which is pretty straightforward, basically just a Raku module. Then you have a command line tool, which is Async for Sparrow itself. Let's get started with our first example. Let's create a Bash script, which is just echoing hello from Bash into stdout and run it using S6. So obviously we have the same stdout that we echo in a script. Now let's modify the Bash script and see how we could use Sparrow to pass command line parameters, name parameters to this script. So we just modified it a little bit and add config function, which reference a named parameter, which is called language, and run the same task passing language named parameters, which has value Bash. So we have the same output, hello from Bash. So we could even have a default parameters for our Bash script by just creating a config YAML file, config.yaml file, sorry, where we could define default parameters for default values for name parameters. So let's create a config.yaml with a default parameters, which in our case is shell, and run the same task. So we could see output change to hello from shell. Okay, so we could even pass different parameters by just separating them, comma. So all those examples shows us how easy to run just a Bash script using Sparrow and add extra functionality to Bash. So someone is talking. Sorry, yeah. Without adding any extra Bash code. Well, and another really cool feature in Sparrow, we could run the same script, the same Bash script as a Sparrow function. So let's create a simple code example, and we use Sparrow 6 decile, and we could use task run function, which basically runs the same Bash script and pass name parameters to it. So, and we have hello from Raku now. Another cool feature of Sparrow, it's called task check. So task check is basically a special file where you could define rules to check your script stdout. You could use standard Raku regular expressions. So in our case, so we define that our stdout has to have either Bash or Shell or Perl or Python or Raku. So we define this check and we run the script, and we could see this stdout is checked. So stdout matched. Okay. And if we pass, say, basic as a language parameter, so we could see the check fails, and we could have respected exit code. So another cool feature of Sparrow is called hooks. So I'm running out of time. So as you can see, we have a lot of cool features in Sparrow, and please check all them out in Sparrow documentation pages. I think I'm run out of time. Am I?
That was a 1 minute warning. You still have another minute.
Oh, 1 minute warning. I have just one minute. Okay, cool. So yeah, so hooks allows one to basically run another task from main task. So you basically define another task, and you use run task function that run this separate task from main task. And Sparrow will take care about all these. You don't need any extra bash coding for that, which is pretty convenient. So yeah, unfortunately, I don't have enough time to cover all that. The last, I would say, killer feature of Sparrow is packaging. So after all, you could package things up and just creating a meta file which describes your script or your task. You give it a version, name, and description, and you use Async upload command to upload a task as a plugin or as a package. And then you just run a web server. It could be Nginx. In this example, this is Caddy, which is I believe written in Go HTTP server, and you serve your plugins remotely, so that someone else could use the plugin on their machine by just referencing the plugin name. So we have a hello language plugin, and we run it. We pass the same language parameter as we did in previous example, and we have the same script in our machine. So all this magic is done by Sparrow. So you don't have code anything. You could use HTTP, HTTPS, Async, or FTP protocols, everything that supported basically by nowadays modern software systems. And there is a sparrowhub.io, which is basically a public repository of existing Sparrow plugins, which now is more than 200 plugins. You could check them out, you could use them. There is a documentation for every plugin, and it's just ready to run. That's it. Thank you for listening.
Okay, that's it for your first one. So switch your slides.
Right. Yeah, let me.
Start when you're ready.
Yeah. Give me just 1 sec. Let me.
Switching slides. Does anybody have an ad they want to?
Yeah. So let me find another link. Just a moment. Almost ready. Bear with me. Let me share my screen. So web URL. We have. So can I go ahead?
Yep. Wait till everything pops up and then go for
it. Does anyone see my screen? Is everything is okay?
You're good.
Okay, let's talk about another birdish things today, which is called bird. Well, bird is a fancy bird, which is basically alternative, which is a tool to check your Linux service infrastructure using Raku DSL. Okay, so again, I'm going to be very practical here. So bird is installed as a Raku module. So you might also need SSH pass if you wouldn't want to run bird against a remote host using SSH. And if you want to supply passwords in command line. But so essentially what bird is, you create a rules. So every rule is represented by a function, which is pretty self-explanatory. So you might check if directory exists, if file exists, if file has certain number of lines, if file has certain permissions, and if package is installed, so on and so forth. So you have this rules file where you define all the checks. Okay, this is just a valid Raku file. Okay, so let me see if I can rotate my screen. Anyway, so and then you run bird. So bird is basically command line for bird tool. So when you run a bird, it does two things. So first of all, for every function, it runs underline bash code. So for example, to check that package is installed, it runs yum or dpkg command line. So for Debian, it's going to be a different, okay, and it produces some std out. So we have a list of shell commands, each command for each function, or more than one command for each function. But so in at the end of the day, they all produce some output, text output. Yeah, so you could see here. So and the second step of bird, so because bird is built on top of Sparrow, and you remember this task check function of Sparrow, I mentioned it in previous talk. So Sparrow would analyze a std out and would verify and would check the assumptions. So for example, if so we want to check that file has certain lines, has certain lines in content. So Sparrow would go to the specific block and would check that it has specific block which is limited by markers, this and this. Yeah, so we would check that it has hello and bird lines, so things like that. So, and we have these task checks. So every task checks basically is either true or false, and we have a verification stage done. And it's really attractive feature because that means bird doesn't require any software installation on a target host. Besides, it only needs standard things like bash or yum, whatever. Yeah. So because it doesn't do any real checks on target host, it's only produces std out using underlying standard commands and analyze a std out using Sparrow, which makes bird really efficient because it doesn't require, again, any software installation on a target host. So say you want to verify remote host, you're not going to even install anything on your remote host. Okay. So, and yeah, like I said, Birds allows you to run, have 1 minute, that's completely fine. Allows one to run checks on local host or SSH host. You could even have a host file which basically a valid Raku code that should return an array of hosts, and you could run the same checks on a list of hosts. Okay, and which hosts will be checked individually, but it's going to be done in just the same session. Okay, you could also might have colorful output. I'm not going to show it here, but believe me, it's pretty amazing. So, and so there is a documentation for available function in Bird. Documentation pages. So I've been adding new function constantly. So we have a list of function right now, but I'm probably going to add more functions soon. Thank you very much for listening and watching. If you're interested, feel free to reach me out. I use my last name as a nickname in Raku RC channels or in GitHub. Thank you. That is it.
Any more advertisements while we get our first set of video up? Andrew, anytime you're ready. The next two being actual videos might be interesting to follow the chat. I see him moving, but I can't hear anything.
Hi, I am Bruce Gray, util online. Reading files can't be this simple. This is how you read files in Raku line by line. It isn't the path.io that is so incredible. That's just a neat shortcut to get a file handle. No, it's this that should not work. Not efficiently, maybe not at all. For and lines. Everyone knows you need a while loop, not a for loop, to read a file. It's a iterables versus iterators thing. Completely incompatible. Let's look at Java. Our task will be open a file bigger than memory, do something with certain lines, stop reading on some condition. So I made a big file. It looks like this. We deserve concise, convenient code for common tasks. Java 8 and 9 added a great lazy streams API. This is very close to Raku. In this file, walk me over all of the lines. No, you can't use a stream in a basic for loop. Stream is an iterator. For takes the iterable. That was very jarring for me. If you leave that beautiful streams API in the approved way and try and mix it with the base language, you lose all the laziness, slurp the whole file into memory, crash and burn. Lots of languages make it easy to do this by accident. It turns out there is a way in Java, but when it isn't taught as an idiom, takes 2 hours to discover online, needs 3 imports, and ends up looking like this, I won't call it a convenience anymore. Frankly, it left a bad taste in my mouth. Several languages try to give you a shortcut with a for each method, but their lambda syntax is lacking in loop control. I don't have time to delve into the cool bits of clever in the Raku design of lines, like how it enables Unix filter operation, or how dot lines on a string versus dot lines on a file are 2 different code bases designed to produce the same effect, so you never need to think of the difference. There's no time to explain how the sequence class is the genius bridge that closes the gap between iterables and iterators. But because Raku really does make for work with iterators, Raku's loop control and multi-paradigm design give me complete freedom to express my solution however makes sense. So, common tasks in Raku. More freedom, less choking. Thank you.
Hi, my name is Bill Michels. I'm here to talk to you today about getting started with Raku Regexes. Briefly, I'm a biochemist by training, most recently at UCSF, and I found a need to do some text processing, converting text files from one file format to another. What I'd like to talk about is some resources within Raku, some of the key features of the regexes that I've been able to take advantage of, and hopefully an individual case. As anybody who's attending this knows, the Perl family of languages is synonymous with text processing. For somebody who might be stumbling across this talk, Perl 6 was renamed Raku in 2019. These are the three domain-specific languages that I would like to be using together. SQL languages, Raku, and the R programming language. The resources that I found really useful for me are Damien Conway's talk, Everything You Know About Regexes is Wrong, also a PDF that's available on the web, as well as a talk and slides that are available from Zoffic's ZNet called Wow Perl 6. So let me just cut and try to get you an idea what I was working on. These are the files that I was downloading. This is called an array design format file. It gives the list of this particular micro array and how it's formatted. We come down here, it's columnar starting at page, starting at line 20, and starting at line 2909, we start seeing these DNA sequences over here. And this is really what I need to work on and extract, but I also needed to massage this into a format known as FASTA format. But before I did that, I had to understand a little more about regexes and Raku. And this is just a test file that I was using to teach myself how to do Raku regexes. These are two genes. YW is tyrosine tryptophan, human activator gamma, and epsilon. And if I run these, I can see that, of course, the genes match themselves. These are three different ways of writing matches in Raku, using the match operator in the first two, and then using the smart match operator in the third. I think the smart match operator looks fairly elegant. It's also a little more powerful. You can see here that it's smart enough to know that YWHAG matches a string asymmetrically. But here I was finding that what I was doing was creating an anonymous character class, just using the letters G and E to terminate this, these gene names. And I should be matching two left-hand side values, but I was actually matching three. And what I had done was I had forgotten to use the zero-with assertion, which is the string terminator assertion, the $sign character here. And something simple as that was giving me erroneous results. So what really it comes to me is understanding is that you have to really work as hard as you can within those two forward slashes to get the right code. Here what I'm doing is I am creating a named regex called N1 and doing the same thing, and I find that I can use N1 instead of the anonymous character class. That would be very good if I had something extremely complex. And then I can use the $/ operator to pull out the exact matches. N1 is matching the G, N1 here is matching the E. These are the two 5-letter matches in here. So, and this is how you would match a mixture of good and bad genes using a grep. Now, going back to the file that I was manipulating, I would say I probably would want to do this a little more cleanly, but I've basically just taken 10 one-liners and run them all together. And they're going to run one after the other. And I'm going to try to break those out so you have a good idea of what they look like. Here they are. Capture the columns in white space. Delete the characters after the 30 mirror. capture gene IDs in the 2 columns before the 30 mirror, delete the gene IDs in 1 or 2 columns before the 30 mirror, clean up the immediate regex above by deleting 1 tab, taking the next to last a gene probe and making it the 2nd column. This is just really column swapping here. Deleting the single column, inserting a prompt. We have FASTA format has a prompt on its instruction line. Replacing all the tabs with 1 space, and then just adding a new line. Now let's see whether or not this is done. We will go back to that file. It's still chugging away. And there it is, it's finished. So started with 33,849 lines and ended with 67,698 lines, which is the correct number of lines to stop with. So I will stop there, and I'll have to say that this is what I was hoping for. This is the FASTA format, and I do want to paraphrase Mr. Churchill here and say that regular expressions are the worst form of coding, except for all those other approaches to pattern-based textual analysis.
Right, so I was going to talk about next year's and what I was thinking about the year after this one. So there's a brief history of the events which happened in Europe in the past actually 20 years, which is long history, and it was pretty much good for all those 20 years, but yeah, a couple of years it accidentally stopped. And actually there are 2 reasons why it was stopped. The first reason is the human reason. Yeah, so we split the languages, and but the good side is that we have now 2 languages, which is also not bad. The second is the obvious reason, but actually, yeah, so we skipped 2 years of offline conferences, and so probably it's time to return to the normal life. I don't know, actually, this time many people said that they were afraid to go to anywhere, even this year, if everything stops. So I don't know what people will think next year, but probably if that stops, yeah, people will decide to travel again. So I thought that it would be a good idea to just make 2 conferences and just make it back to back, 3 days Perl, 3 days Raku. So this is the calendar for next August, and it perfectly fits the same dates as like this year, for example. It is 6 days in total, so those of you who like both languages will have to spend 6 days. Well, actually, that's not that bad. So I asked in Reddit about Raku conferences, and actually note the number of points. So it's 8 apps, and for the Perl subreddit, it's 23. So that's actually the difference between Perl and Raku, at least in the number of people, which is what we kind of agree with. But yeah, still, I think the reactions are quite good. There are a few reactions, like spend some time in the Gaujas nationalized parts, and like Riga is a nice place to be hosted in. So why not go back to Riga? So actually, it's kind of the place where everything stopped, and it might be the place where everything continues. So actually, yeah, so I booked those days. and yeah, we can try making something interesting, because those of you who were there in Riga can remember that there was a really nice river cruise. We spent about, I don't remember, was it 2 hours, a little bit more, on the, actually it was the biggest available ship in Riga. So yeah, it was good weather, and actually some people skipped, for some reason, some people skipped this cruise, even if they booked, but nevertheless, we can repeat it. And of course, you might remember there's a Lido restaurant. Well, actually it's a restaurant and pub, and there was a good selection of food over there. So yeah, that's all repeatable, and we can continue next year. So I'm looking forward to these kind of events. So yeah, we'll see how it goes in the future. But this is my plans for the next August. So yeah, that's it for this lightning talk.
Last chance. Does anyone have an advertisement? And I will. Okay, then let me. Oh, Anton.
Right, then if it's it with Lightning Talks, we don't
hold
have
on.
any more.
Anton raised his hand.
Oh no,
No, it was, yeah. I also made this. It was clapping. Yeah.
Okay, so to finish up the Lightning Talks, we have them all the time. Remember, we expect that it's a gateway drug. After you've gotten your 5 minutes of fame, you'll realize you're worthy of a 20-minute talk next time. We expect big things from you. The rest of you, next time out, give it a try. And for conference scheduling, it looks like about June in Houston, the third time's the charm on this side of the pond. Details to come later. And now back to you, Andrew, to finish up for the day.
Yeah, thank you. So it was another great day, well, according to my opinion. So it was day 2 of the first Raku conference. Actually, yeah, it's quite amazing to realize that it was the first ever Raku conference, even despite the fact that the language exists for, what is it, almost 20 years, right? And we still have day 3. Tomorrow we start at the same time, 15 o'clock UTC. And we have another 7 talks tomorrow. And there's a slightly, well, there's a small change in the schedule, because yesterday we had the replay of Daniel's talk. Now we have the continuation of Vadim Belman's class, and he will be continuing talking about how to learn Raku from inside out. So it's really, really nice talk, and I think actually when we will have Rakuda Award, the physical thing, we can actually, I can probably even share the screen just to see. Right, so it's the Raku Conference, and yeah, so actually this award will be given to Vadim for his great talk about Raku internals, but that's, yeah, some future plans. But nevertheless, so I think that's it for today, and thank you very much. So we'll see you all tomorrow, and yeah, have a good good evening if you are in America, and good night if you're in Europe.